Thomas, thank you so much for joining me. Generally, when I have someone who's a neuroscientist or a philosopher of mind, I open with the question, what is mind, or what is consciousness? But I think in your case, as a nuclear physicist and with a diverse body of knowledge and work, my question to you is, Thomas, what is matter?
Oh, well, that's just as easy. But once you understand consciousness, what matter is much simpler. I'll answer both of those. Matter is information.
Mm-hmm.
Our matter is really just information. All right, and you say, well, what does that mean? Well, you look at me right through all this electronic whiz we have here, and you see this flesh body, and it looks like matter, doesn't it? But what is it? It's information. It's information that's been collected by a camera. It's information that's been collected by your eyeballs looking at a screen. That information comes out of your screen as what, 1 million little pixels of light. Each one of those pixels has a position, a brightness, and a color and an intensity. That's it. So you got 3 parameters on each of the pixels, and you look at those 1 million dots of light, and you say, "Oh, there's Thomas sitting across from me, and look, he has flowers in the background, and this and that." You see all that, but all it is information. Okay, so matter is information. We get that information through our 5 senses. If you didn't have your 5 senses, if you couldn't see, couldn't hear, couldn't smell, couldn't taste, couldn't feel, what would you be aware of? Where would the matter be? It wouldn't be any, would there? It's gone. You cut off your information sources and you can't experience matter. So matter is an experience, and it's experience based on information. And besides, the definition of consciousness, which is what you would have asked somebody else, that's so easy that let me tell you that too. Consciousness is awareness with a choice. And what is awareness? Awareness is, again, it's based on getting input, right? You're aware of something. How are you aware of it? Well, you're aware of it because you have sensors that gather the information about it. Mm-hmm. So the awareness, part of a information system, if you will, has input. You're aware of the input. So I'll answer both of those definitions. The consciousness self is an information system. It gets inputs, and it looks at those inputs. It assesses them, it interprets them, and then it interprets that data into information. And that information isn't necessarily exactly what the data says. It's the interpretation that the consciousness makes of that data. See, when you look at data that's coming across the screen, the only reason that you can say, "Oh, that's purple flowers and Tom's wearing a blue polo shirt," and so on, is because you've seen flowers, you've seen shirts, you've seen human beings. Because you've seen those things before, you go in and do a pattern match. "Oh, that's Tom. He's a human being. Looks like he's male. He's got white hair and a blue shirt." You see, because you've seen people with hair and shirts and things, so you go pattern match that, and that's what it is. It's all about information. And you interpret that information based on your own experience base. If you had never seen a human being, you'd never seen a shirt or flowers, you'd look at this and you wouldn't know what it was. You might not see anything. You might just say it's just a bunch of scribble stuff. I don't know what it is. It doesn't mean anything to me. So it only means something to you in as much as you interpret it. And if you took somebody that was, say, born in a desert, never left a desert, they'd probably look at all that green stuff and wonder, what the heck's all that green stuff doing back there? What is that? They wouldn't know.
And
they wouldn't have that in their background.
When you say it's awareness with a choice, Thomas, do you want to elaborate on that aspect of choice a bit?
Yeah, absolutely. So I talked a little about the awareness, and it has a choice. Okay, it can choose. Now, in the case of what we were just talking about, it can choose to look at all of its background experience and decide that those are flowers and trees and so on. But that's its choice. It can choose how to interpret that. It might interpret it differently, but it has the choice of how or even whether to interpret it or not. So its consciousness is an awareness, okay, and it's aware of itself and its surroundings, and it gets information, it interprets that information, and it can choose whether to interpret or even whether to accept that information. It can turn it off. It can close its eyes, so to speak, so it doesn't get that information coming through the eyes. So it has choices about what to do with that information, what to turn it into, what to decide it is. I mean, somebody may look at this and come up with something different about it than you and I would, just because they have a different background. Well, then that's their choices. That's how they choose to see it. That's how they choose to interpret it. Art's like that. You have a painting, particularly if it's abstract. Everybody looks at it, gets something different out of it because it's the feeling you get from the art, and everybody's feeling is different. But that's just another choice, and you choose that. So now, choice means once you have a choice, there's a lot of stuff packed in that word choice, as
I
you
was
might
just
have
about to
guessed.
ask
That's why you asked. Yeah. If you have a choice, then you must have time. You can't have choice without time, because there's before you made a choice and after you make the choice, right? Choices make a difference. Okay, so if you have choice, you have time. And if you have choice, you also have free will, because that's the only kind of choice there is. If there is no free will, then there is no choice. Choice is not defined. It's not a thing. It's not a possibility. Everything just is if there's no free will, but there is no choice. So when I say it's awareness with a choice, that tells me that I'm talking about consciousness, free will, and time. All things that have to exist together for any of them to exist. They have to, they're logically connected to each other. You can't have, you couldn't have a choice without time. You can't have awareness, without choice. Well, you
Yes.
can't have consciousness without choice. You can have awareness without choice, but then you're just aware, but you can't do anything about it. So you don't come to any conclusions. You just are aware. So it's entirely a passive thing. You're not interactive at all. If it's interactive, then you have to have choice and free will and time. So all those go together as all three are logically necessary for any of them to make sense or exist. Now, the opposite of that, it has an opposite in philosophy, and that is materialism. And materialism, of course, must be also deterministic. That's the nature of materialism, is that it also logically, if you're a materialist, you must also be a determinist, unless you're not being rational. Those two are necessary for each other. The physicists would tell you that if they knew the exact state vector of every particle in the universe, then they could predict everything else from there on that would happen, because they just look at the rules, and according to the rules of physics, they could predict everything else would happen. That's because it's all deterministic. And if you're a materialist and thus a determinist, you would have to come to the conclusion that consciousness, time, and free will are all illusions. And if you believe that consciousness, time, and free will are real things, then you'd have to come to the conclusion that materialism and determinism were illusions. So those are just philosophically incompatible between those two corners. And of course, we experience time, we experience choice, which means free will, that we do make choices because we want to make those choices, and we experience that we are conscious. We think, we see things, we interact with things. So as far as observation goes, I would think most everybody says, well, sure, everybody every day, almost every minute of every day, observes the reality of time and consciousness and free will. That's kind of standard. But now, over on the other side, they have to somehow say that those things don't exist when we all see them and interact with them every day, you know. So that gives them a pretty hard thing to do. So they really can't. All they say is it's just an illusion. No, we don't know how or why or anything about it, but it has to be an illusion because we're materialists and therefore we're determinists, and we know there can't be any of those things, even though it seems obvious there are. So that's a pretty weak argument. They really don't have a very good argument about that, other than if materialism is right, then those three things have to be illusions. And science has a very deep and abiding belief in materialism. It's a belief, just like any belief. It doesn't happen to be true, but it's a belief that's very deeply held by most scientists, actually, not just scientists, but most people in our culture. It's a belief that's inherent in what I would call Western culture.
Mm. I think it's important to acknowledge that, because as someone who's firmly grounded in a very materialist perception of reality, I think it's easy to also see how scientism can easily grasp someone and hold them very tightly with that belief system. And many scientists are often blinded by this belief system, thinking that, okay, they're gathering information using this tool, this wonderful tool that is science, but not realizing the normative application of their own values, belief systems within this system. And they become very blinded to this. How do you feel this has happened throughout the years?
Oh, well, some of it's historical, and that is that before there was science as science, before that was really a thing, there was religion. And the religious belief, just like any belief system, it grows till it gets very dogmatic. And when it gets very dogmatic, then if you don't believe it, then obviously you're wrong, and maybe you even need to be gotten rid of, because you're a heretic. So that was the pressure. The high priests of, I don't know what we call it, of our culture, we're all religious people. The high priests are the people that tell us what to believe, and they were religious. And if you were not with them and that made you against them, well, that was a very serious problem that could cost you your life. So science kind of grew up with that going on, and the idea that all that belief stuff was just really not helpful. We need science. We need to have a scientific method. We need to determine what's real and what isn't real and how things work, without having, these beliefs imposed on us. But what happened is, after the success of Newton and success of a science called optics, these are old sciences. People have had lenses and light, going back to the medieval times. So with Newton and Newton's laws, which is kind of an amusing thing too, because they turns out they're really not laws. They're not even right. They're only approximately right in the macro world. They're approximately right. But in any case, the scientists kind of felt that if you can't see it and you can't measure it, then it doesn't exist. Because all of the belief stuff that was troubling them, that the church was imposing upon them, like Galileo under house arrest, right? All had to do with things you couldn't see and couldn't measure. So the scientists had this real strong attitude about, if material world is all the world there is, and if you can't see it, you can't interact with it, you can't measure it, then it either doesn't exist or doesn't matter. It's irrelevant. That's called an operational definition of reality. You can operate on it. Operate, I say make a measurement, but operate means you interact with it somehow. You have to be able to interact with it. And that seems pretty plausible in the beginning. If you can't interact with it, well, then you can't interact with it. Where is it? What is it? So they throw that away. But the problem with that is that the more meaningful part of our life falls into that area of being not real, hallucinatory. So you have the objective world. Oh, that's the stuff you can measure. That's the stuff you can interact with. But the subjective world is really where most of the action really happens for most people all the time. I mean, the subjective world, that's where love is. That's where cooperation and caring and justice and interaction and, all of the things that are significant, relationship. I mean, if you look at the objective and the subjective, the objective part are like the props on the stage. It's the stuff. The subjective, stuff is the actors and their thoughts and their feelings and what's going on. Well, nobody goes to a play to watch the props. The props aren't what's interesting going on there in that play. What's interesting are the people and what they're saying and their attitudes, their feelings, and their interactions. That's what's important. So when physics got to this place where it said, the reality is just what you can measure, nothing else. Well, what they said is that everything that wasn't material was irrelevant, was imagined, a hallucination. So that means you go to the theater and what the actors are doing is all hallucination. And you should really just go interact with the props. Well, of course, that doesn't make any sense at all. So by doing that, they felt that they were securing the space where religion would no longer come in and tell them what they had to believe. All right, well, what happens is now, so a couple of centuries later, we have that the physicists are the high priests. It's the physicists that tell all of us what's real and what's not real. And we pay attention to them. And they say this is a materialist world, nothing exists but materialism, and that's it. Well, then all that subjective stuff is not covered there. It's not real. Just like time isn't real, and consciousness isn't real, and free will isn't real, can't be real. It's all just an hallucination. Well, that's obviously not right either. We know that, our subjective reality is important, it's significant, and it's the larger part of us. It's the more meaningful part of us. It's not just the little part that we can ignore. It's the big part. All of our relationships with other people are all subjective. Okay, they have objective bodies, but the relationships are all subjective. Well, they're all hallucinations. You only think you have a relationship. There is no relationship. You see the problem we get into? So the physicists, you say, well, how did it end up like that? They wanted to kind of inoculate themselves from the beliefs that they had to struggle with all through the 16, 17, hundreds and before, and things that got them burned at the stake or in house arrest. They wanted to make sure that didn't happen anymore. And they wanted to focus just on the things that they could understand. They could write equations to describe. Because all that other subjective stuff, well, what is that? Where does it come from? How does that work? What are the rules? They didn't have a clue. So you tend to focus on what you can do, and you tend to ignore what you don't understand. So that's how we've ended up with a science that has this belief in materialism. And what they basically say is that, we just work with the objective world because that's the only world we really know exists. The rest of it, is an illusion, and we just don't deal with that.
Mm.
That's not hard science. And the only science there is, the only real science is hard science. That's kind of the way they feel about that. Hard science, that would be physics, chemistry, biology, that sort of thing. And the further up you go on that list, the less hard they get. You get into biology now, you start to have squishy things that aren't quite as hard as you had before, because you have things like consciousness. But in any case, they have then become the high priests with very strong beliefs and with very strong dogma, just like the high priests that they supplanted. So you get rid of one bunch of high priests, and you end up with another bunch of high priests that are also dogmatic. And if you don't agree with them on that basic nature that materialism is all there is, then you're a fool. You just, you're a kind of a mushy brain person that makes up a lot of stuff and believes it. So unfortunately,
it's very, sorry, Tom, continue.
Yeah, they got caught in the same trap that they tried so hard to avoid that trap that they actually made the same trap for themselves and are deeply caught in their own trap. So deeply caught. And here's a real good example. About 100 years ago, in the 1915 to 1925, somewhere in there, quantum mechanics was discovered. It became a science. And it became a science because of the double slit experiment. And the double slit experiment very clearly says that there is no matter, that the fundamentals at the bottom of the pile is probability and statistics. It's information. It's just information. And it's not only information, but it's information that's dealt with probability. So that was a problem for physicists, but actually it wasn't a problem for the guys who did that. They were all thrilled. Oh, wow, we got a whole new view of the world, and they were all excited about it. But they didn't know how to deal with it, all right? That's great. It's new. Now what do we do? How do we describe it? What's its point? How does it work? Well, they came up with nothing. And they came up with nothing. And these are all a bunch of really smart guys. We're talking about Planck and Bohr and Heisenberg and Schrodinger, Wigner, all these guys. Einstein was in there too. We're talking about all the smartest people that the world's seen for a long, long time, and they hit the wall. They couldn't come up with anything to do with it. We have quotes from Einstein saying that, yeah, we know that consciousness has something to do with it, but I don't have any idea how to deal with that. I can't write an equation of consciousness. I don't know what it means. So they just hit this wall and weren't able to take the next step, which means explain why, consciousness was connected. Well, consciousness was connected because if the information about what they call the which way data, which slit the particle went through, if that information was available, they got one pattern. And if that information wasn't available, they got a different pattern. So they realized that information being available to us made the difference. The observer, it's called the observer effect or the observer paradox sometimes. So they knew this was a big deal. They knew it changed everything. They knew materialism wasn't that answer, and they knew that it had something to do with consciousness, but they could not figure out what or how or why. So 10, 20 years go by, 30 years, and they basically give up. They say, nobody will ever know. It's impossible. It's just weird science. So we're sticking with materialism. Plus, we'll add in this weird science that this doesn't fit materialism, but it's just weird science. Materialism is really still the thing. It's just we'll overlay it with some weird science sometimes, but we know how to calculate that weird science. So, the famous quote, so shut up and calculate. Don't ask us about what it means. Just shut up and calculate. So that was kind of the attitude then of physics. So Now, I have that perspective. There was a perspective that they were missing. What is the perspective that makes this all make sense? What has the perspective from which we can derive quantum physics? Not just empirically see that it works if you make these assumptions, but derive it from first principles. And it's not weird science, it's a logical science. Now, really understand, why does it work? And things like, why is the speed of light a constant? That's another big mystery. They don't know. And there's all kinds of things they don't know. Like, where does time come from? Where does space come from? Where does charge come from? Where does mass come from? You ask physicists, well, where does all these basic things that you guys work with come from? And they'll say, well, they just are. Well, they just are. That's not science. That's mysticism. So at the very root foundation of physics is mysticism. They don't know what all those things are. They just are because they are, is what they'll tell you. It's self-evident that they are. Now, and anyway, so, if you understand consciousness, you can derive physics from it. Consciousness is fundamental. Consciousness is the base of our reality. And like I say, if you understand consciousness, you can actually derive quantum physics and relativity. Why c is a constant, speed of light is to c. Why, the double slit experiment turned out the way it did, why it had to turn out that way. So you try to explain that, though, to physicists, and the paradigm shift is so great, it's such a big paradigm shift that they can't grasp it, because it takes them, of course, away from their belief in materialism. And actually, it's not just a paradigm. It's like, it's like three paradigms, one up against the other, shifts that they have to make, plus a bunch of deductive logic, which they're perfectly capable of doing. But when you see that, then everything falls out. And not only do you derive from first principles a more general physics that subsumes the physics that we have, plus adds quantum physics to it as a rational, logical science, but you also end up with a science of the subjective. So now you can understand the subjective well. So all of those subjective things, that stuff about relationships, all of that becomes clear. You can understand, why is it that way? Why is that relationship that way? Why isn't that relationship a good relationship? Why is it a bad relationship? So you can tell that. So now you have a science of the subjective, and you get that just with having a different perspective, seeing these paradigms change, but they can't go there. They can't see it. It's just too big a jump. Now, that it was going to have to be a really big jump, because if all these scientists for 100 years couldn't figure out what the perspective was that made it all make sense, it's not going to be just a little bit different than what they were used to. It's going to be totally off the wall, bizarro, crazy kind of thing. Otherwise, they would have figured it out in 100 years. I mean, the best minds on the planet have been banging their head against that wall for a century and come up with absolutely nothing so far. So it is very far out there. Consciousness is fundamental. And, we live in a virtual reality computed by consciousness. See, that's what? Whoa, where did that come from?
Before you get to that, I mean, a big part of why I started this podcast was actually an opportunity to explore these diverse ideas in a way where people can come together from different backgrounds. So I want a scientist. I want someone who's very hard scientist to come here, listen to you speak, but I don't want them to immediately shut off, because I notice the moment someone says something like that, consciousness is fundamental, or we live in the matrix. And if you take down your theory, I mean, that is pretty much what you are saying. We live in the matrix. I don't want them to immediately switch off and then just change the channel. I want them to understand, okay, let's ground this in a way, and let's give you the opportunity to explore this idea in the rational, coherent way that you want to explain this. And something you do is, because I notice that there are physicists nowadays coming to the conclusion that, look, reality, space-time, Donald Hoffman's one of them. I mean, you've got all these people who are concluding that this reality is not fundamentally what we think it is. Now that's the first premise they need to sit with, and now obviously try and figure out how do we practically apply this new information to the way we live. And I think that's what stumps a lot of people, is the moment you draw this new conclusion, okay, reality is the matrix. Now what do you do really? If it's not practical, if it's not applicable, and then there's no point. And that's where you were headed with physicists just give up at that point. But you find a way to, I mean, you have a theory of everything. It explains consciousness, physics, philosophy, and a lot of these views. And we'll slowly get towards that. But let's now discuss, okay, you conclude consciousness is fundamental, and now what?
Well,
or first, do you want to discuss why you fundamentally conclude that or make that conclusion?
No, if I talk about, how the logic that brought me to that solution, we'd be here for at least 2 or 3 hours. We can skip over some of it. I can kind of do a quick, zip over the top. But
it's a highly technical summary, in essence.
Yeah, I could do that, but you talk about, okay, so that's the way. If that's the way it is, so what? What does that tell us? What does that leave us? But the answer to that is it leaves us with a whole new physics, a whole new view of reality. Every time we have a big paradigm shift in physics, we usually get new technology, we get new ideas. I mean, all kinds of things bubble up out of those paradigm shifts. Once you understand reality better, it opens up all sorts of things. And one of the things that it has done, in science, there's lots of things called paradoxes. Well, like the speed of light's a constant. That's the paradox, and quantum physics says that, there's uncertainty at the root of everything, that there's probability. Well, those paradoxes, there's lots of paradoxes like that. There's bunches of paradoxes. There's lots of paradoxes in biology. There's paradoxes in, science in general. And there's paradoxes in what, the people that study old artifacts, that kind of stuff. It's just paradoxes everywhere. And one of the things you get with this is all those paradoxes dissolve. They're not paradoxes anymore. They have rational explanations, simple explanations. Oh, that's why the speed of light's a constant. Oh, that's why some critters can evolve faster than would be possible just if it were random. It's not random.
Do you want to give us some of those explanations, Tom?
Oh, well, sure.
Just pick some and just give us.
Just pop up a couple of them. There's a thing called the anthropic principle. I think a physicist wrote a book about that. There's some what they call cosmic constants that physics has. And let's say there's, I'm just making stuff up now, but the concept's still there. I don't know the details, so I'll make those up. But let's say there's 4 or 5 constants that the physicists have found. And these constants are numbers that have, 15, 20 decimal places to them, as long as how much we can measure them, how precisely we can measure them. But they found out that of these constants, if any one of them were to change in, say, the 9th decimal place, the whole universe would be unstable and wouldn't work. So the only way that this universe has stayed here for all these billions of years is because these set of constants are balanced perfectly. They're tuned to each other. And that was a discovery, I don't know, about 20 years ago, and there was a book written about that. So that's a big, wow, how did that happen? Because if all this evolution is random, how do you randomly get 5 independent constants that are all in tune with each other to 9 decimal places? That's not random kind of thing that happened. That looks like it was done just to make a universe that we could survive in. So that's why they call it the anthropic principle. Looks like it was made for us. Well, if you understand how this virtual reality was created, it tells you exactly why you get those. Okay, this virtual reality was not programmed. It started with a rule set and initial conditions. And when you hit the run button, the initial conditions would change according to the rule set, and you let it evolve. Well, what's that? What are those initial conditions? That's the ball of plasma, the Big Bang ball of plasma, high energy, high temperature, and what are the rules? What we call science. That's the rules. So you let that thing evolve, and what do you get? You get this universe, and eventually you get us, and everything that's in it. So that evolved. Now, was the system so clever that it just got the right rules and the right initial conditions the first time? Of course not. So it's big digital bang, take one. Oh, that didn't last long before it bombed. Big digital, let me fiddle with that a little. I'm going to turn gravity down. I'm going to, adjust this and that. All right, big digital bang, take two, and by the time you're up to big digital bang, take 10,000, you've got this thing tuned so that it works really, really well together. And you've got all your constants, all your initial conditions picked just to make this thing work, because that's what you're trying to do. You're trying to make that. So if you see how that works, then of course you'd end up with a bunch of things that were tuned together. It was made specifically for us. That's truth. So, it solves that problem. Another thing that's been a problem is, the speed of light is a constant. And why that's a constant is because in a virtual reality, the fast that you can move, the highest speed that you can move through a virtual reality, and when I say move, I mean move continuously, from pixel to pixel to pixel to pixel, not teleporting, but just moving from one pixel to the next. It's 1 delta x for each delta t. That's it. If every delta t, every pixel of time, you move 1 pixel of distance, you can't get through reality any faster than that. You can get through it slower. You can move 1 delta x for 50 delta t. But if you move 50 delta x for 1 delta t, well, now you're teleporting. You're disappearing at this place, and you're appearing 70 pixels over, or 50 pixels over. So to move contiguously from pixel to pixel, fastest that you can go is 1 delta x for 1 delta t. So
would that a system be something akin to a quantum entanglement or some sort of a spooky action at a distance? Would it explain that in any way?
Well, sure, it explains that as well. But see, we're not down, it explains all those things. How does entanglement work? How is it that you have something here and something 100 light years someplace else? You make a change here, you instantly get a change over there. Okay, well, that's because this is a virtual reality. You've heard of if-then statements, right? If this changes, then that changes. It's a computed world. There is no space. Space doesn't actually exist. Space exists because you take a random point, and you say, that's the origin. All right, now I'm going to have 3 unit vectors, x, y, and z from that point, and that defines all space from plus infinity to minus infinity everywhere. Now I got a 3D space. Well, that space isn't fundamental. You see, we think it's fundamental, just like we think mass is fundamental. It's not fundamental, so it's just computation. The reality requires, for logical consistency, for that entanglement to happen. So how does it happen? It's an if-then statement. That's how it happens. It's part of the logic of physics. It's part of the logic of the rules. If you look at the rules say this can happen. All right, so it happens. That's why it is. Now the speed of light is a very important little number, and we say it's constant, but it's changed a little bit. Again, out in that 8th, 9th decimal place. And since we've been measuring it, we can measure it, say, out to 10 or 15 decimal places. Our measurement's gotten really, really precise. But this is like at the 9th, 8th or 9th decimal place. It'll change just a little bit. Sometimes a little higher, sometimes a little lower. It just changes. Well, that delta x and delta t, the delta x divided by delta t is the speed of light, right? 1 delta x for every delta t. So that is the speed of light. Now, let's say I want higher resolution. See, delta x and delta t tell me what the resolution of the system's going to be. But now my avatars out there are, putting out the, accelerators, smashing particles, doing all kinds of things that require me, the creator of this virtual reality, I need to make it a little higher resolution because those people are digging a little deeper. So how do I do that? Well, I need delta x and delta t to be a little smaller. I need a smaller delta x, a smaller delta t. That gives me better resolution. But I want the ratio, the speed of light, delta x over delta t, to remain the same. But this is digital. I can't make it exactly remain the same because these things come in chunks. I can only get close. You see what I mean? Okay, let's say if you just mathematically could say, well, I'll take delta x and I'll divide it by 2. And I'll take delta t and I'll divide it by 2. But if you did that, you'd have 10,000 decimal places, maybe an infinite number of decimal places. The world's pixelated. So you can only approximate that to the nearest pixel. So when it wants to do that, it says, all right, let's have the time and have the distance, and we'll have higher resolution. But I want to keep C the same, but I can't make it exactly the same. I can say that, well, if I added, if I made time, 1 pixel less, it'd be too big. 1 pixel more, it'd be too little. So I have to pick whichever one of those is the closest, and it's not going to be exactly the same because our reality is pixelated. It's digital. It's computed. So that's why you get that little tiny change, and that tells you where the resolution for this reality is, and that resolution just got up a little bit.
And then within that framework of thinking, within this virtual reality or computed nature of the universe, if you to, let's say, flip the equation a little, let's say you're trying to figure out time, delta t over delta s at this point, what type of relationship dynamics would change here fundamentally with our perception of this new reality or virtual reality?
I'm not sure I understand what you're asking me.
So if we try to understand the nature of time from this perspective, and you flip the delta, so delta t over delta d, the distance over time, if you had to try and figure out what time is in this one, so delta change over time, so if you had to multiply the both by time and then divide by, let's say, how would you figure out what time is here?
Well, time is created here. Yeah, it's saying like what is time? Let's just say what is time, and where does time come from? Okay, well, time is just the outer loop. It's the delta t. Okay, so that's time. Now, delta t, the way dynamic simulations work is that there's always an outer time loop, and you have the simulation that tells you how all things move and change. So then you increase delta t, 1 little delta t, and you recalculate everything. All right, something was here, but it's moving, so now the next delta t, it's over here. So the next delta t, it's over there. So the way simulations work is that there's an outer time loop, and every cycle through the simulation, you recalculate everything with the new time, and it tells you where all the stuff went. You see what happened next. All the rules, all the rules that are dynamic, that change with time, then change. So that's the simulation. So the system has a timepiece. The consciousness itself has a timepiece. It's digital. So you just have let's say you have a thing that goes from 1 to 0, 1 to 0. Digital has lots of 1s and 0s, but we'll just take a little piece of it and go 1 0 1 0 1 0. We've got a clock. That's a metronome. We have a clock. So now we have regular time based on this clock. So consciousness clock is much higher resolution than our clock. There's like a billion ticks of the fundamental conscious clock for 1 delta t in our simulation. That gives the consciousness computer lots and billions of cycles in which it can do whatever it needs to do between every one of our delta t's. You see, so we have that kind of thing. So it's just our delta t was set to be whatever it needed to be to give a decent resolution, no more than necessary. So when we were all cave guys walking around dragging our knuckles on the ground, and everything was done in the macro world, there wasn't anything digging into small spaces. Well, then the resolution didn't have to be so big. The resolution was maybe only 2 decimal places, or 1 decimal place probably was good enough. And any computer simulation wants to have no more resolution than necessary, because the more resolution, the more crunching you have to do, the more calculation you have to do. And if you're not using that information, then you don't do it. So you keep the resolution as low as it can be without anybody noticing that it's digital, because you want this to seem like it's a continuous place. You don't want it to seem like it's digital. You want it to seem like a motion is smooth, not the jerky motion we got, back in old video games, right? Because everything was too slow. Well, you don't want it to be like that we're walking around like this, and we can't invent things like cars or airplanes because we're all that jerky motion, we'd kill ourselves. So it wants to look nice and smooth. So to do that, you pick a resolution that works. And then as those people start digging into smaller spaces, you're going to have to change that resolution. But you don't want to change it any more than you need to. Now, the bottom level of where you can change it is our best guess in physics, is that's what we call Planck time and Planck length. And that's very, very small. But our resolution doesn't have to be that small, because that's way smaller than anybody would, it's much more resolution than humans need, even with our atom smashing and everything else. That's very, very small. So so what's time? Time is been set at delta t. Just like you make a simulation, you pick a delta t, and that's how you run your simulation. Well, delta t's been picked. And when that delta t ends up to be too big and they need something a little smaller because people are making better and better tools for measuring things, then you have to lower that delta t. But when you do, you got to lower delta x2, or you're going to change the speed of light. And the speed of light is a pretty important constant. That a lot of things kind of are based on that. So you want to keep that speed of light the same. So that's why you get those numbers. That's why the speed of light changes places. There's all kinds of things. That little readiness potential that you find in muscle tissue that shows that your arm is getting ready to be raised before you're even aware that you need to raise it. Well, that readiness potential is an artifact of consciousness. It's trying to get a slow electromechanical device moving, a body, a physical body. And, consciousness moves a whole lot faster than that. So it needs to get this body moving so that we don't have lag time, because this body would not, this body in this virtual reality would have a lot of lag time in it otherwise. So this little readiness potential is the system knows what's going on, what's going to happen next, because it's computing the whole thing. So it says, well, we got to get this body, you got to get this arm ready to move, because otherwise these humans are going to be looking like, 1980s video games if we have all this lag time going on. But they've got these slow electromechanical bodies that have to move. I mean, to get that muscle to go, you got to put, squirt some hormones in the blood and let the blood bring it around to the particular muscle tissue, and you have to do this and that, and all that stuff is really, really slow compared to the reaction times that are necessary to make nice, smooth, well-coordinated action. So that's another one of those things that it's just, well, how did that work? There's lots of these paradoxes that you just don't understand, but they're perfectly clear once you get what's going on. So that's what it does. Well, so what? Well, the so what is it's better science. It explains more. You understand more. And besides that, you can predict new things. You can get a science of the subjective. That before it was just, nobody knows how that works. That's just stuff, but if you understand consciousness, all that subjective stuff is about consciousness. That's what it's about. And there's a science there too.
Tom, you mentioned that. You mentioned you indirectly mentioned it, but Libet's experiments with the readiness potential. A lot of the approaches of someone, let's say in a materialist view, trying to argue the fact that, look, we don't really have conscious experiences in the way we think we do. This illusionist view is based on these premises of, okay, a lot of this is happening during an autopilot state. Everything's happening in very unconscious states. And a lot of the time, we don't really even know about the things that are happening while they're happening. So, for example, while that readiness potential is occurring, I mean, there's a lot of unconscious inferences occurring. And how do we explain these unconscious behaviors or the lack of control over the system that's controlling us in a sense?
We don't control the system that controls us. We're being computed. Okay, we're being computed, but we're being computed according to a rule set. We're not just computed any old which way. There's a rule set that says how we have to be computed. So our consciousness, we talk about our consciousness, maybe call that little c consciousness, that's our own personal piece of consciousness. All right. Of course, it doesn't know everything. It's just a little piece of consciousness that's logged onto this avatar to make the avatar's choices. There's a consciousness system out there that's actually doing the computing. We'll call that capital C consciousness. That's the system doing the computing. Now, we're a little subset. We, not we, the body, we, the piece of consciousness that's playing that physical avatar, me, the individuated unit of consciousness that's playing Tom Campbell, the human being, all right? Now, that consciousness, works at high speed. It's consciousness. It's an information system, and it's an information system with a much smaller delta T than we have, with a faster processor, if you will. But this virtual reality game we play has a rule set. And that rule set has all these electromechanical things going on. Okay, so the system has to account for that. And as it turns out, the humans were kind of laggy. They weren't doing very well. They're kind of laggy. So there's all kinds of things going on that our consciousness is unaware of. Okay, our consciousness is a player of an avatar. Okay, so look at it this way. When you play a game, when you play Sims or something, you're the player. You are that character's consciousness. Your Sims character doesn't do anything if you don't tell it to do something, right? You make all of its choices. Okay, so you log on, and when you log on, the system starts showing you pictures of your character, and you get to make choices what you want your character to do. Stand up, sit down, get a beer out of the refrigerator, whatever you want it to do, you have to tell it to do that with your joystick and your keyboard and your mouse and whatever tools you have to do that. You tell it what you want it to do. So then you go tell the computer, hey, I want it to stand up. So the computer sends back a picture of it standing up. All right, so that's the way the system works. Now, from the viewpoint of the Sims character, the Sims character feels like it's in a sim world. Right? From the viewpoint of the Sims character, it's in a physical world. From the viewpoint of Tevin and Tom's bodies, we live in this physical world. And from the viewpoint of the avatar, it lives in a physical world. There's trees and water and streams and houses and people and whatever in that physical world. And the player and the computer are both non-physical relative to the perspective from inside that virtual world. All right, so here we are, our bodies. We think they're physical. We live in this virtual reality. Consciousness is non-physical to us. The consciousness system, the computer that creates this, is non-physical to us. The player, us. I'm really an individuated unit of consciousness. I'm not this body. I'm just logged on to this body, and I'm playing it. Okay? So once you get that idea, there's a whole lot of things that change in the way we see reality. Like, for instance, the virtual reality only exists in the minds of the players. Okay? That's a fact. There is no virtual reality where little, elves and things are running around. It only exists in the minds of the players. All right? So there's a reason of why there's this thing called the paradox, where with the double slit experiment, a consciousness has to be involved.
The observer has to be there.
Yeah, the observation paradox, there. Well, because in the virtual reality, to put something inside this virtual reality, it has to come in through the mind of a player. If it doesn't come in through the mind of a player, then it doesn't get to be here because it only exists in the minds of the players, you see? So that tells you why that happens. It also tells you that everybody lives in their own reality. There isn't a reality out there that is the reality that we all live in. That doesn't exist. The reality is in our minds. It's a data stream that our consciousness gets, and it interprets that data stream. And how it interprets that data stream is based on its own understanding, its own history, its own ignorance, its own fear. All those things go into it. It interprets the data, and that is the reality. So you live in a different reality than I do. You see, we don't really live in some physical reality out there that is independent of us. Physical reality is us interpreting the data stream that we get. So now you have these things like what? A Mandela effect, right? Where people say, well, this used to be that way and that used to be this way. And these things changed. And well, guys, there is no reality out there that used to be any which way. The reality is in consciousness. The data exchange between the consciousness that's playing the computer and the consciousness that's you, that you're a piece of. So it explains a lot of events, a lot of things we see now suddenly have explanations that they didn't have before. All the things that used to be paranormal, now they're just normal. It's just a part of consciousness. And you realize that everything paranormal takes place in the intuitive side of consciousness. Consciousness has two paths that it processes information, intuitive side and intellectual side. The intellectual side uses logic. Intuitive side uses intuition that's non-logical. It's beyond logic. There's information available out there because the rendering engine that creates this reality has to have certain databases available as it needs the data. It computes this thing called a probable future reality, or the probable future. The future's not a done deal, but there's a probable future because a reality, this is another thing, when people think about a virtual reality, they think of something that's computed from the ground up. Well, a virtual reality, you'd have to compute subatomic particles, which then would make up the atomic particles, which then would make up the molecules, which would then make up the macro world. Well, no, that's ridiculous. It's too hard. It doesn't work that way. There's too much, to do there. That would be an extremely stupid way to do the computing. If you were a computer scientist, that's not how you choose to do it at all. That would be, even if you could do it, that would be horrendously wasteful. Can't do it, but if you could, it would be very wasteful. So what do? Well, you take those rule set, you got the rule set, which defines how everything works. You can create some samples, calculations from that rule set about how things work. And you can create probability distributions about how things work. And my example I tend to use, because it's so simple, is that look at an old Civil War cannon. And it's a real simple thing, right? It's a cylinder, and at the end of the cylinder, you put something that burns fast. You put a wick down to it, you roll a ball in, on top of where the stuff that burns fast, and you light the wick, and the stuff burns, creates pressure, and the pressure pushes the ball out the other end. It's a real simple tool. It's a real simple thing. All right. Well, to compute that from the subatomic particles up is impossible. Even that simple machine would probably take all the world supercomputers a month just to get one ball out of the tube. There's so much going on there. There's so many molecules, so many atoms, so many whatever. It's stupid to try to do that. So what you do is you take the rule set that defines that cannon, the stuff it's made of, the imperfections. It's not really a perfect cylinder. The ball's not really a perfect sphere. The powder doesn't burn all at once. It burns in some random pattern, and you got all this stuff going on, and the barrel gets hot, and after it gets hot, it changes its characteristics and shape, and all sorts of things are going on here. So you do all of that with a rule set. Look at the variables: heat, how many balls have been fired, all this stuff, and you turn it into a probability distribution. Now, okay, a cannon's fired. They light the wick, boom. You put the ball there. You go into a distribution of all the places that the cannonball are likely to go and the probability they're likely to go there. So that's a probability distribution of the possibilities. Now, you could make up your own. Let's say you had a cannon and you fired 100,000 times. And then you go out and measure where all the balls are. You go collect your 100,000 balls and measure where they landed. And from where all those balls landed, you create a probability distribution, right? Well, you can do this in software as well. You can just take the rule set and do that. And it only takes microseconds because you're a very fast computer. And you can compute that. Now you've got this probability distribution. So now you got a civil war going on, and there's 10,000 cannons going off all over the place. And all you have to do is take a random draw from a probability distribution of the possibilities, and that's where you place the ball. That's where the ball hit. You see? Now, that is much, much faster than trying to do a bottoms up for all 10,000 cannons all going off. Trying to do that all from the bottoms up is ridiculous. So you make models, and you can have very good models because you have the rule set, which is mostly deterministic. The rule set's mostly deterministic. So you can make these models as accurate as you want, up to as many decimal places as you want, up to how much accuracy do you need? In a Civil War cannon, if I just made the ball go here and that was only accurate to 1 decimal place, who would know? There's not a bunch of Civil War guys out there saying, oh, that ball landed in the wrong place. The ball lands where the ball lands and you go play, right? It doesn't matter. So you don't have to have everything really precise. It's
so
no more.
Reality needs to be useful rather than completely predictable.
Exactly. So you have this reality that has to be done in terms of probability, because to do it any other way is a dumb choice from the computer science viewpoint. And you have everything you need to make those probability distributions. You've got the rule set. You know how everything works, you see? And you are simulating it. You know what all the possibilities are. So you have those tools. So that's why our virtual reality is based on probability. It's because that's the only thing that makes sense. Now, and I guess I'll make this point. If you had something that went from the ground up, you see, you have a way of knowing what's going to happen next. I know where everything is now. I know the dynamics of everything, so I know where everything's going to be next. All right, but now you have a probability-based reality. You don't know what's going to be next. You see, you don't have that material all that connectedness. You don't have that anymore. So the way the system determines it is it takes a random draw from a probability distribution of the possibilities, and that's what happens next. So, for instance, take a scientist who's got a telescope, and it's better than any telescope's ever been before, and he's going to look through it, and he's going to see more than anybody's ever seen before. So what is it he's going to see? Well, one thing is all the things that telescopes have seen in the past, they kind of say what's possible. To some extent, they define what's possible. So now what's he going to see? He's going to see out further. Okay, so you look at all the things. Now the system knows, because the system has all the rule sets and knows knows where everything is, right? It's computing everything. So it says, what are the possibilities? And what are the probabilities of those possibilities? Take that random draw, and that's what that guy sees. He sees that. Now, if that guy goes, wow, great, here's my picture, I just took it and I'm going to publish it, and the house caves in on him and he dies and the picture gets destroyed, and another scientist says, okay, well, I'll rebuild it, and he takes a look in exactly the same place. Will he see exactly the same thing? Not necessarily. There'll be another random draw from a probability distribution, and he'll see what he'll see. Now, once he sees it and he does publish it, anybody else looks there, they have to see the same thing because that's now been part of the virtual reality. It's come in through the mind of a player, and now everybody, sees the same tree planted in the same place in the same yard, right? You have to have that consistency. So that's the way it works. So it's suddenly, it changes the whole way we look at reality and the way that we see how things work. And it solves a lot of philosophical puzzles too. It tells you the big battle for millennia over it wasn't materialism, they called it realism versus idealism. Well, idealism's it, guys. realism realism doesn't do it, so it settles those kinds of arguments. So, so what do you get? So why? What's the point? Well, the point is it's better science. It's better understanding. You understand your world and how your world works much better than you used to. You've gotten rid of all your paradoxes. You understand how things happen. You understand that consciousness is non-physical from our perspective here. It's not a physical thing. It's a non-physical thing. And you understand that space, well, where is it? If it's not here, where is it? Well, it's not a good question. Where is you got in your head a 3D space viewpoint. It's somewhere in space. Well, no, space isn't a real thing. Space is a computed thing. Consciousness is the real thing. The only thing that's real. Everything else is a virtual reality.
A lot of people like to ask, where is it and what is it? But I feel like a good question is also like, why is it, Tom? From this perspective and this theory of this virtual reality, is there a teleological perspective coming through here?
Absolutely. Absolutely.
What would that be and
why is it? Okay. See, what I do in my book is I start with the smallest possible piece of consciousness. Okay, we said consciousness is awareness with a choice. So here's a simple little awareness, and it only has a choice that's it can be in state A or state B. That's it. I mean, if it could be in state A or state A, then that's not a choice. It has, that's the simplest choice you can actually get down to, right? It can be in state 1 or state 0. That binary is the simplest choice that you can have of an awareness. All right, so that's my basic consciousness cell, if you like. Now, if you look at consciousness as a system, and you say consciousness is an information system, right? It deals with information. It gets input. It assesses that input. It makes choices based on that input. All right, based on the assessment. So if we have a consciousness system, and that's an information system, how do information systems evolve? Okay, assume you have an information system and all the bits are random. Well, there's no information in that system. It's not really an information system. It's just a potential information system. If you order some of those bits, now you've created information, because those ordered bits could stand for something. You could say, all right, I want that to stand for, the number 2. I would like that to stand for this or that. I want this to stand for when I feel happy, and I want this to stand for when I feel sad. You can give it whatever you want. You can give it meaning if you have something there other than randomness. So information systems evolve by lowering their entropy, by creating order out of disorder, creating order out of randomness. Okay, so now that's what they do. So now I'll start with my one little cell. So how does it evolve? Okay, it's evolved. It's conscious. It's aware. It can be in A or B. How does it evolve? It could say, well, now I'm in A, and now I'm still in A, and now I'm in B, and now I'm in A, and now I'm in B. Well, that's A, B, A, B. It's made something. It's a pattern. So it could create patterns. It can create patterns of patterns. Then, if it says, well, if I can just be in A, if I can take one of these states, A and B, here on the side, and I'll just flip that back and forth, A, B, A, B, A, B. Oh, well, now I have a clock. I've made myself a little clock. And now I can have sequences of patterns of sequences. And the more order I give it, the more complex it is. then the more the bigger are the ideas, the more it could stand for. So now it could obviously come up with arithmetic rather easily. It's an A and an A, or a B and a B, and if it's two A's and two B's, that's four things, or it's two A's plus two B's. Arithmetic would follow very easily from that sort of a thing. It's just natural. Arithmetic would be a natural thing. So math would be one of the first things that it would learn to understand. When you get down to it, computers aren't so much brilliant about advanced math as they are really good at adding. They're basically adding machines that can add very, very quickly. So if you crunch it down to what's actually going on down at the guts of the computer, mostly you got a fast adding machine there that makes it look like it's multiplying, dividing, doing integrals and differential equations and everything else, but it's doing it, adding, is the root thing that it's doing, adding positive and negative things together. So adding and subtracting. So anyhow, so you get this thing and it learns math and it learns things and it makes little symbols and patterns that it likes and has meaning for it. Okay, it's a consciousness, it's aware, so it gives meaning to those things. And it evolves then to have more and more complex and more interesting and more meaningful patterns. Now, meaningful, it's not just bigger and more complicated. So that could just get bigger and complicated just for the fact of getting bigger and complicated. That's not the point. The point is it has to have meaning. It has to have significance, not just complication for the sake of order. It has to have significance. So that lowers its entropy. So it keeps doing that, and eventually it gets to a place where it's not evolving so fast anymore because it's kind of done everything it can think of. It's worked the math out to as much as it can use, and it kind of stalls because it's just one monolithic thing. Well, how do you get more novelty, more things to do, more meaningful patterns? Well, it's the same thing our cells did. When we had single cells, amoebas, well, you have amoebas and they can only do so much. But if you get cells that cooperate, now you get multi-celled things. Now, multi-celled things can do all kinds of stuff, and now you got fish and jellyfish and other stuff that are multi-celled things, and then they have special cells that just do digestion and just do locomotion, and special cells that are sensors, and special cells that control all the rest of the special cells. So you have cell differentiation, and all of this is getting lower and lower entropy, more and more complexity, but it's also getting more and more meaningful and significant and adjustable. When you have just one thing, well, there's so many things you can do and you're done. When you have a lot of things that can interact, well, you've got a lot more possibilities going on here. So what does the consciousness thing do? It takes a piece of itself and gives it free will because it gives it choice. It says, all right, you go out there and make choice too. Now these things can interact. So then it makes a lot of those things so they can interact. And now the possibilities of what they can become together, what kind of multi-celled thing could they create with all these consciousness cells, you see? What could they do? So now it becomes much greater as far as its ability to evolve into more interesting lower entropy states. So what it does, just like biology did the same thing. And see, I'm doing the evolution, and it follows the same kind of evolution that biology does because these things are obvious. When you're just a one thing, you can only do so much. When you're multiple things working together, you can do more. So anyhow, it does that. And eventually, these little pieces of the larger system, I call them individuated units of consciousness. That's what you and I are. And dogs and cats as well are individuated units of consciousness playing avatars. Okay? Mm-hmm. So the way that works, and then you can say, well, how did we get there? Why build this virtual reality and so on? So there's real good answers. This is the teleology, whatever the word is. you get this because, all right, the system now is more complex and it's got a lot of pieces. Now these pieces you can think of as just subsets of itself. A virtual machine within a bigger machine, right? If you're a computer guy, then you know what a virtual machine is. It's just a subset of a larger machine that looks like a little computer in its own self. Well, that's what these are. So all these IUOCs are just virtual machines inside the bigger information system. And eventually, of course, you need to make a virtual reality so that these things can communicate with each other. Because if you just make them, there's no language, there's no vocabulary, syntax, none of that is done. So the first virtual reality is communication protocols. Now I call that a virtual reality because a virtual reality is defined as a reality based on a rule set. It's an informational reality based on a rule set. There's no rule set, then there isn't a reality. You have to have a rule set to define the context of the interactions of the piece parts. So the first virtual reality was the system saying, well, I've got all these IUOCs now, but we need to interact. We need to communicate. So the first virtual reality was it created communication protocols, vocabulary, syntax, things it needed to interact. And then after it had that, they could all interact within this virtual reality. But it's a virtual reality, so they interact. All right, growth picks up again. Evolution starts chugging forward a little faster now, but again, it plateaus. And why does it plateau? Because the virtual reality they're in, which is just the communication definition of how to communicate, that's a very limited reality. There's not a lot of consequences to that reality. Okay, you can decide who you communicate to or who you don't. You can lie. You can tell anybody anything you want. It's like a chat room with no rules. So it doesn't have the experiences that really challenge the possibilities of these pieces. So they're limited in that kind of a virtual reality. So the system says, well, I need a different virtual reality. I need a virtual reality that creates choices that are more meaningful, more significant, that help us evolve by lowering our entropy. Okay. Now there's two big things going on here, two big points to make. One is that by now they have a social system, right? Consciousness has become not just a monolithic system, a consciousness, it's become a bunch of consciousness, a social system. If you have a social system, how does a social system, now that's consciousness, now is the social system, what's the obvious way to lower entropy in this system of consciousness, the social system? Well, if you've got a bunch of interacting pieces, the way you lower entropy is by those pieces cooperating, by those pieces working together, caring about each other. The opposite of that, which is high entropy, is if those pieces are all just out for themselves and don't give a damn about anybody else. If they think up something nifty, they keep it for themselves. There's no trust. There's no need to get together or to work together or to build anything. It's just, you see. So then we have this idea that what consciousness needs to do, and the big outcome of making all these individual units of consciousness, is you create this social system in consciousness that has to cooperate in order to make a bigger, greater thing out of itself. Okay? So that sets what's the driving force here? Cooperation, caring, learning. I put that over on the love side. Okay? Becoming love, caring about each other, optimizing what we can do together, as opposed to us all just fighting with each other. All right, so now it has a way to lower its entropy, is to cooperate. But it still needs to lower this entropy. So it still needs a virtual reality in which these choices that bring it toward cooperation and caring and whatever take place. So it can experience those things. So that's when the system says, well, look, I'll get this set initial conditions, and I'll come up with some rules, and I'll run it. And when it bombs, I'll adjust it, and I'll run it. And when it bombs, I'll adjust it until eventually it gets this virtual reality that's the one we live in. We live in this virtual reality, and it was evolved for consciousness to interact with. So it was designed for us, yes. And it did take a whole lot of iterations before it was stable enough to evolve all the things that it evolved. So that then, you see, it gives us a why. That answers the why.
Yeah.
Why are we doing this? Well, because the information system has only two choices. It can evolve, become more useful, more interesting, more fun, more stuff going on, learning, growing, or it can de-evolve and end up all the bits are random, which means death for the information system. So just like anything else that's evolving, it's evolve or die. Those are basically your choices. So the system wants to evolve. It doesn't want to turn out to be a bunch of random bits. So it would like to evolve, and it has ways that it can help itself do that. And one is to build this new virtual reality wherein there are choices that are very meaningful. So it creates this virtual reality we call the physical universe. It's got all kinds of creatures that have grown up in it, and the system's played all of them like all NPCs for a while, but eventually it says, okay, here, you IUOC, you start making the choices for this piece. Log on and make that piece's choices. I'll stop making that piece's choices. And it got the IUOCs to log on, make the choices of the pieces. And those pieces, of course, were us, humans, Homo sapiens, Neanderthals, saber-toothed tigers and shaggy woolly mammoths and things like that. And we all were interacting with each other. And how do we grow? By the choices. And our choices now are life and death. I'm hungry. My family's hungry. We're starving to death. But look at those people. They've got food. Well, I'm bigger than they are. I'm just going to slap them and take their food. Is that a good thing to do? Or do I ask them if I can join them? And could I please share a little bit? And I'd help, I'd work with them. Or how do I approach that? So there's all these choices. And by these choices, we evolve or de-evolve the quality of our consciousness. Quality of consciousness means lower entropy is higher quality.
It's important to note, because I notice a lot of people, sorry for cutting you off there, Tom. I notice there's a bit of a lag, by the way, so I might need your recording of this after we're done. So if I ever do interrupt you, there seems to be a bit of a lag. There's such an irony here, knowing that we're talking about lags and systems within a virtual world. And today of all days, we seem to be having some sort of a technical issue. There's a massive storm outside. I think that's the main reason. But I wanted to ask you about this system, okay, this virtual world that we're living in. It's important because you mentioned love as this core factor as to how to get things together. And I think it's important to acknowledge that you're not saying this in that almost wishy-washy way, and it's very much a very scientific observation from your perspective, because you're talking about love here in a very cooperative manner. For cooperation evolves complexity, and at this point, that's what you're referring to. Not really this almost spiritual sense of it, but rather there is a scientific
absolutely
construct.
Absolutely. Matter of fact, it even comes up with a scientific way of defining love. It's the nature of a low entropy consciousness. Yes, it is. I mean, we're talking about cooperation. Cooperation builds complexity. Complexity is lower entropy. Lower entropy is evolution rather than de-evolution. So see, now we've just set the stage for all these things. But see all the benefits we get from that. All kinds of philosophical things just got answered that have been hanging around for years. Why are we here? Well, we're here to grow up, become love, to evolve. What's our purpose? And are we all really one? Well, yes, we're all part of the same larger consciousness system, but we're also individual. We're virtual machines. So we have, all the same capabilities as the larger system has, except it's smaller. We have less capacity, but all the same capabilities. So we can do all those things? Can we get information from the databases that the system uses to generate this virtual reality? Sure, we can. Those, if you go back in time where people have figured this out. I mean, the Buddha 2,500 years ago said, this physical reality is an illusion. Well, yeah, that's the same as saying it's a virtual reality. It's an illusion. It's not the real thing. Or Plato in his cave saying, it's the shadows on the wall. That's what we think the reality is. It's just the shadows on the wall. So we've had these arguments going on for a long time. And now you can understand exactly, yeah, I got it, Okay, shadows on the wall, but that's not very satisfying. That's something that's very abstract that you can't really do anything with. But this actually makes all of it kind of concrete. It says, yeah, this is the way it works. You have consciousness. It's fundamental. We're subsets of that consciousness. And here, we have this virtual reality that was created for us to play in so that we could make better, we could lower our entropy through better choices. The system would like to help us do better because as we lower our entropy, its entropy is lowered because we're it. We're a part of it. So it wants to help us. The system, you can think of it, did the system just instantly become full of love? No. The system had to learn just like we did. When it got all of those IUOCs, it said, okay, IUOCs, we're going to cooperate today. Here's what we're going to do. And the IUOCs with free will said, nah, forget it. I'm going fishing, I'm doing something else. So what did the system say? You guys get back here or I'm going to, take you apart. It tried to bully them. It tried to coerce them because it hadn't grown up yet. And it found out just through trial and error that if you bully and coerce, you make everything worse. If you had problems before, you get bigger problems. That it has to be cooperation. It has to be with caring. So the larger consciousness system learned to work with us, learned that our free will was sacred. You don't mess with our free will. We have to make our own choices. It doesn't butt in. So you have all these attributes and things that it learned. And there had one guy who was at Gonzaga University. He was in charge of, I don't know, Catholic studies or something like that. And he says, that makes sense. That's the Old Testament versus the New Testament. The Old Testament, you've got this angry, jealous God that's going to turn you into pillars of salt if you don't behave. And in the New Testament, it's all about turning the other cheek and being love and cooperating and being a good, being a good player for the team. So he says, well, that suddenly makes sense to me. And I said, yeah, well, that's all our, we put down, we register, we remember, we tell stories. That's part of the human, what do we call it? Maybe archetype, the human mindset. We have all that information in there. Yes, that's the way it started. Me, angry, jealous gods who were trying to bully us, and then it turns out that that's really not the way it is. The angry gods grow up and learn that love is the answer. That's the way you have to deal with things if you want to optimize. So all kinds of things just fall out. This idea that consciousness is invisible. Like you go out of your body. You're not in your body.
Yeah.
Your body doesn't even have there's no brain in here. There's no heart in here, no circuit, no blood running around in here. The system only has to model what you see. It doesn't have to model any of the rest of that stuff. But now if you go cut my head open, it's going to have to model a brain. And if you go digging around in the brain, it's going to have to show the connections that the rule set defines, where all this stuff evolved. So if I'm in an automobile accident and I have brain injuries and I slur my words, I drag my left foot and I can't remember anything, my consciousness isn't damaged, but my consciousness has to play this character who drags his foot, slurs his words, and can't remember. You see, he has to play a character like that, and he's limited in the things that he can do. So it makes it tells us things like, we have had paranormal things around for a long time, like the placebo effect. That's a paranormal effect. You talk about something and it actually changes your health. You get more or less sick based on what the doctor tells you. Well, that means that the mind is affecting the physical body, right? That's a mind over matter. It's a paranormal thing. Well, how does that work? Well, you find out that your intent modifies future probability. That's one of the ways the system works. So that explains why there's that power of positive thinking. Where did that come from? And that power of negative thinking too. It takes you down into a hole. So all these things that we've known about for ages, for millennia, suddenly have good scientific, logical explanations of why they work like that, which means you can build more on top of it, your understanding. So like any big paradigm shifts, this just starts kind of an evolution in greater understanding as we work out the logical consequences of what all this means. I've only worked out some of the most obvious logical consequences. I'm sure there's lots more out there that will be worked out, later on by people. So the so what is a very big so what, it kind of changes everything. It totally pulls science up at its roots and gives it a different perspective, puts quantum mechanics as a logical science, not a weird science. Explains a lot of things. Like space time.
You mentioned quite a few. Sorry, Tom. You mentioned quite a few things there. I just want to quickly before we move on from those, because there's so many things there that I find very fascinating, and I want to touch on. I'm just going to leave these 4 questions with you quickly, just in case I forget about it. One is, you mentioned the Old Testament and New Testament, and I find it very fascinating the way people take your information in from what you're talking about within this matrix, virtual world, or simulated reality, and then people draw the conclusion that, okay, this is proof that God exists. So I want to ask you, actually, what are your religious views, and how do you feel when people take this information you provide them and draw very religious conclusions?
Well, I've had some of those. I had some people tell me things like, everywhere I go, I carry 2 books, the Bible and my Big T.O.E, and the people who, of course, my Big T.O.E has no dogma associated with it. There's nothing you have to believe, It is totally just science and logic. But people will do with things whatever people do with things. You can't help that. People are people, and they have always their own paths of growing, and that's fine. So if somebody wants to say, well, is the larger consciousness system really God? Well, I don't use the God word in my books anywhere. I purposely avoid all of that because, well, depends. How you look at it, what you think God is. Most people have their own definition there. And it is not perfect. It's still evolving. It's an evolving system. It's not infinite. It doesn't necessarily know everything that's going on everywhere all the time. It has to focus its attention to different things like we have to focus our attention to different things. Okay, it's got more capacity than we do, but, no, so it's not omniscient. It's not, it had a beginning, someplace we don't know. That's, in my book, I don't say it's beginning. So I actually had an interesting thing happen. I was at a church, because churches are often free venues, so I was at this church, and it was in Atlanta. It was trying to think of the name of it, but anyway, I had two people there, a man and a woman, who were both doctorates of theology, and they listened to my talk. And afterwards, they were there, and I called them up, and I asked them. I said, "Well, you've heard my talk about this. Tell me, what if you had to list the attributes of God? What would you list? I don't want any dogma. I don't want anything that's sectarian. I just want what you think the attributes of God are." So they did. They huddled off, and we did some other things. I answered some other questions. We came back when they were done, and it was a unity church. Okay, they're a little less dogmatic than the average church. And what they came back with was a list, and everything on their list was also an attribute of the larger consciousness system. So, I didn't know how that would work out. I was just curious, how it would work out. But They were all attributes of the larger conscious system. So in their mind, the larger conscious system was a good model for God. Now, if you're a more fundamentalist of some sort and have a lot of dogma in something, then then the larger conscious system is not going to be your perfect, omniscient, forever, infinite, etc., because it's none of those things. It's finite. It's not perfect. It's evolving. It's not done. But so that depends on who you are and what you think God is and what God means to you. But in a way, this model also has answered a lot of fundamental questions in theology, because it not just answers physics questions and physics paradoxes, but theology as well. It does kind of fill that function, but no, I wouldn't call it God. And my own religious viewpoints is sometime when I was maybe 15 or 16, I gave up on religion altogether as being kind of a silly thing that didn't make any sense. I couldn't find the logic in it. I've always been a kind of a logic guy. And as I got older and learned to be logical myself, and by the time I was in school and working in physics, I would have called myself an atheist, or at best an agnostic. Probably more likely to call myself an atheist than an agnostic. And as I started working on the My Big Toe stuff, it was just, it made me laugh. I had any number of really good laughs as I came to these conclusions, like love is the answer, we're all one. And I had to laugh at myself, and I'm saying, what you've done, atheist, is that you are coming to the same conclusions that are the fundamental basis of most all of the main religions. That's what they're saying. Now, they've got a lot of other junk added to it where they've added their own thing, but if you just look at the basics of it, I've got a lot, the Buddhists and I agree on all kinds of things, and even the Christians, and even I have a lady that is a follower of Muhammad, Islam, and she loves My Big Toe. She thinks it's everything that I say. She says that's exactly what's in the Quran. It's exactly, it's all there. And people say, Tom, are you a Tibetan Buddhist? I've been studying Tibetan Buddhism for 20 years, and everything you say is just like a Tibetan Buddhist. And I say, no, I'm not a Tibetan Buddhist or a Buddhist or any of those things. And people will come up and say, Tom, are you a Kabbalist? What you say sounds just like the Kabbalah. Tom, are you a shaman? You sound just like the shaman of, so I get this all the time, where various religious and other kinds of groups find themselves in My Big Toe, because My Big Toe is totally open. It's not exclusive in any way. They're just concepts. Use them as you will. Do with them as you want. If they help you understand the world better, then great. If they don't, then ignore them. Throw them away. So I do run into that a lot. But
yeah, I can imagine. I mean, it's something that I've seen come up quite a lot. I mean, I've seen people like literally say, "You prove that God exists." But let's touch on the watched.
Yeah, I would say no, that's not true. I don't prove anything of the sort. I prove that a larger consciousness system exists, and if you want to call that God, that's up to you. But I wouldn't put that word in your mouth, right? I have to keep this science. I want it to be science. I want it to be logical. I don't want to have anything that isn't logical or science included in it, because that just weakens it. That just
Tom, within this matrix or the virtual world we live in, how similar or different is it from the actual movie, The Matrix? I mean, The Matrix is one of my favorite movies of all time. When you look at that concept, and when you have you watched The Matrix, by the way?
Yeah, I watched all the ones in The Matrix. That's a long time ago, because those are old movies. But yeah, I watched it. But yes. Yeah, there's some very big differences there. Yeah,
what were your thoughts on it at the time?
I'm sorry, we're talking at the same time. Go ahead.
It's this lag on my side. But once I get your copy of this, I'll definitely try and edit this out for people just to help them out.
Okay. I've seen some lag too. I've seen where you're frozen a couple of times. I haven't seen
is it?
myself
Yeah, no,
frozen.
you haven't frozen my side, but on my side there is a slight delay in the speech.
Well, anyhow, there's some things that about my Big Toe that are not the same as the movie The Matrix is. But the basic idea that we live in a virtual reality, of course, that's the same, and that the reality is computed, that's the same, and that a computed reality can be just as real as real can be. You can't fault a virtual reality on, well, it's not really real. For the matter of fact, I would say that the only thing that's real is consciousness, and what is real? Information is real. That's it.
Yes.
Everything else that we find in our reality, or part of what we call real, is derived from information. It's part of consciousness. So consciousness is fundamental. Information is real. I just kind of leave it that simple. And that's true. That seems just to be true. Now, there's a lot of physicists who say that our reality is information based. That's not hard to get a physicist to say that. But for them to then say that we live in a virtual reality, that they won't go there, because that has other connotations, and they don't know about that. They'll just say that this reality that we have seems to be information based. Most of the atomic physicists and the quantum physicists kind of gotten around to that point, but they won't step past that because it conflicts then with their belief of materialism, and then they just can't go there. So the science. I have physicists that have read my books and love it, and they're on board with it. I have a lot of computer scientists that think it's great. A lot of engineers and otherwise technical people who like it and agree with it and think it's good. But most scientists won't even look at it. It's not. They don't have the ability to actually look and see what's there. They cannot do that. That would burn their eyeballs out or something. They just cannot get themselves to do it. And a few of them I've gotten to listen for a short time, but as soon as I stray from things that they know from their materialist viewpoint, it's And I have so many objections that I have to explain to them that we never actually get to where we need to go. So they never actually see it. But I did a paper. I have some experiments, physics experiments that I've done. I don't know if you're aware about that or not, but one of the authors, it was my experiments that I delivered at a talk in LA in 2016. And in the audience, there were these two guys. One of them was from Caltech, and the other one was from JPL, which are both out there near LA. And they both got around and said, hey, let's get these things published. I think it's great. And I think you got something. So I have physicists from high-powered institutions who think it's this right on, but they are the exception by far. I just had a young physicist about a month ago that I thought I could, but he found so many objections so early that I never actually got him to see the paradigm shifts that I wanted him to see, because he got hung up over a lot of other things first. And, there's only, you can only Zoom for so long before it's time to quit. In this case, he was up really late at night, and it was midnight, so we just had to quit. But he didn't get it, because a new paradigm is hard to get. I mean, just imagine back when the people said, the world's really round, it's not flat. You can just see all the people say, well, that's ridiculous. If it were round, the people on the other side would fall off. That's stupid. It can't be round. That doesn't work. If it was round, all the oceans would just spill off the edges and disappear. So anybody with a brain knows that it has to be flat so that people don't fall off, and that the water doesn't just run over the edges. And, a round Earth is just a stupid idea. And you can see that trying to convince people of that is very difficult because it takes a whole new concept called gravity, and that's not an obvious concept. It's not like, oh, gravity, yeah, that makes good sense. Yeah, we're all attracted to the Earth. I can see that. So new paradigms are really hard to get people to wrap their arms around them because they're so contrary to what they already believe. And they have all these really good reasons of why that couldn't possibly be true, which is, of course, all their beliefs that they've collected up to this point with their ideas.
I must say, when I first, I think this conversation that you and I are having probably would have been impossible for me personally, at least about 5 years ago, because of the same thing you're talking about. I think you have to sort of be slightly, almost just exposed to it a little bit more in micro doses in order to slowly step out and kind of explore this. It's almost like microdosing yourself with idealism, and I think that's what's happened with me over time. I mean, you have enough chats with people like Bernardo, Kastrup, Donald Hoffman. Over the time when you explore these concepts, you can see the logical, coherent steps you're taking to make these fundamental, life-altering conclusions. It's not that you're just stepping out into a wacky realm, which is how a lot of materialists would view it. It's that you're actually just taking logical steps into a different framework.
Yes. But even the people that you think would get it very easily, let's say like Bernardo Kastrup, right? Idealist, one of the more outspoken idealists that we have around today. And I had a little conversation with him. It was videoed, and one of the things he said was, he says, well, one of the problems that idealism has is, where is this information? It's you were talking about consciousness and information, and he says that, all right, the information, we live in just the shadows on the wall, but where is all this real stuff going on? That we're the shadows of, and we can't produce that. And I told him, I said, well, that's not a problem for idealism. I says, I can tell you about the information. I can tell you where it is and how it got there and where it came from. And he looked at me and changed the subject, and I got immediately like, nope, impossible, can't be, it's impossible, we just can't know that, and you must be, off on some goofy thing that whatever, so he kind of wrote me off just like that. Now here's somebody who's been in, this idea that, and he would agree with me, consciousness is fundamental. He agrees with that. But yet he couldn't. Now, I didn't do a whole thing like I've done with you, explaining it all. I didn't have time for that. This was just a chat that we had. But I could see that obviously in his mind, I was a crackpot of some sort that didn't know what I was talking about, because that's impossible to know about that invisible, not here stuff. So I run into that even with the people who should be on my side. They're still not on my side, and I talked with Donald Hoffman, and it was a similar kind of thing. And I was talking with Donald, and he was talking about how this was mathematical and that was mathematical, and I said, well, Don, the mathematics isn't really that big a deal. The mathematics is the logic of quantity. Okay, a lot of things in our reality can be described by quantity. So math really describes our reality well, because, how tall is it? How heavy is it? What is its density? These are all quantitative things. And I said, that's good. But I said, you don't need that. You don't need math to prove that it's a real theory. I said, science isn't done with math, though many scientists believe that. Science is done with logic. Science is done with rational logic that makes sense, that means things. I said, that's what it's done. And a model should be called good if it can answer the mail, if it answers all the questions, answers new stuff, doesn't add any new paradoxes, that sort of thing, then it's a good model. And doesn't have any crazy assumptions in it, or doesn't have many, only has one or two, has very few assumptions in it, then that defines a good model. A good model's not defined by how well it agrees with what we already believe. Now, unfortunately, that is what makes a model a good model to most physicists, is that whether or not it agrees with what they already believe. But, he felt that if he didn't couch what he was doing in mathematics, that nobody would take it seriously and it wouldn't mean anything. It wouldn't be real science. And when I tried to say that, no, you don't need that. Look at, excuse me,
Sorry.
got a little something in the throat here.
Me too.
Cough, making you cough.
Yeah. No, I actually had that for a while, and I think I just kept it up.
Anyhow, look at the biology. Okay, we have evolution. Evolution is a science. Biological evolution, that's good science. It's damn good science. Go out and get all that data and make all that logical deductions from it. And it's answered a lot of questions like, why do dolphins have finger bones in their fins? Things like that. It answered a whole lot of things that were paradoxical. Well, I said, that's science. But that's not very mathematical. There's a little mathematics here and there in the statistics, I guess, but it's just reasonable. It has data to show that it works. It makes sense. It answers the questions of why are things that we observe the way we observe them. I said, that's what makes science. You don't have to impress people with your mathematics that you've got real science because it's mathematical. Matter of fact, when it comes to big picture things, the mathematics will be a hamper. It will just get in the way because the big picture isn't mathematical. It's ideas, it's understanding, it's logic. That's the big picture. If you try to understand consciousness with mathematics, it isn't going to work. That's not what's going on here. These are conceptual. These are ideas that help us understand the world that we're in. Ideas that logically can explain things and new things. And, I said, because he was just so hard over on it has to be mathematical or it can't be right. It can't be useful. And that's not true. If physics is looking for, well, where's the math? Well, you don't need math. It's where's the logic, where's the reason, and where are the answers that nobody else can get? That's the thing. And where are your assumptions, and how many assumptions do you have? Because, you can do like string theory, and if you have 10 assumptions or 14 assumptions, each one of their dimensions is like another assumption. If I have 14 assumptions, that's like playing a game of cards and I got 14 wild cards. I get 14 assumptions, I can prove almost anything. So you have to look at it and judge it by its value, not by its math. But he kind of wrote me off because I wasn't as mathematical as he would have liked. So if it's not mathematical, then it can't really be science. And that's just wrong. It's not it at all. Mathematics is a tool because science talks about the physical world. The physical world tends to be measured mostly in quantity. It's a quantitative thing. So yes, math does a great job at doing that. But now you're not just looking at the stuff in the world. You're trying to look at what does this stuff come from? What is its origin? What is its nature? Why is it there? What is your purpose? And you're not going to find your purpose in mathematics. You're not going to find that sort of thing. You have to understand the bigger picture. So even the people that should be on my side, or at least open, I find that when I talk to them, they're closed off. They don't want to go there. And they too will not listen to the whole thing because they get to a point that is against what they believe and gone. That's it. They're done. Because if I'm against what they believe to be true, then obviously I'm a loose cannon and don't know what I'm talking about because I couldn't know those things. I have lots of people when I tell them, well, what happens when you die? And I tell them what happens when they die. And they say, well, how could you know? How do you know it's that? That's impossible. You can't know that. That's impossible to know. So you must be making it up. But it's not impossible to know. You can find out those kinds of things. That stuff is available. And these paranormal things, they are real things. You can get that information. It is available. You can modify future probability. And all these things, science has shown that they're true. You can read some of Dean Radin's books, and he'll show you that there's been plenty of people who have done good science with good protocols and shown that, yes, these things indeed are facts. But nobody ever can go the next step because they're facts without a reason. They're facts without a theory. They're facts without anything logical to support them. They're just facts that hang out there all by themselves, and I can't use them. It's that sort of thing. But my theory puts a scientific foundation underneath all of that stuff. But even the people that are kind of leading my way think consciousness is fundamental, think that this is a virtual reality, like Hoffman. They hit the eject button. When early on in the conversation.
Yeah, no, I think it's strange in the sense that, that you all three are clearly idealists in the sense that you fundamentally agree that reality is consciousness, and there's no disagreeing with that. No. And I've spoken to both of them twice in very long format conversations just like this, but I can understand the psychology behind the differences at some point, because even within physicalist, materialist thinkers, there's always these fundamental differences that creep up once someone says slightly different to their own belief system. And it's just a normal way of thought at this point.
Well, the way it works is that nobody thinks that they have beliefs. You see, if you have a belief, then in your mind that belief is a fact, because you believe that this is true. Well, you don't believe that this is a belief that it's true. You believe that it's true. So when anybody has a belief in their mind, that belief becomes a fact. Now, a fact is something that's incontrovertible. It's a fact. So when I say something that they know for a fact that isn't, that's contrary to that fact, then boom, the whole thing blows up. Because in their mind, they don't say, oh, well, that's my belief that you can't do this, or that you can't find out, or that you have to have math. It's not, they don't see it as a belief. Nobody sees anything as a belief. They see things as facts. That's the thing. That's why you need to get rid of beliefs. Beliefs are a bad thing. You need to get rid of beliefs altogether. And when you do, you'll peel away a lot of those things that used to be facts when you get rid of your beliefs. So it's just normal. Yes, it's normal psychology. People convince themselves that this is true. They believe it's true. It's a fact. And you come and say, well, that's not true. X, they hit the X button and you're gone, because they know you must be wrong, because you have just contradicted a fact that they know is true.
I think it's good to have a balance of being passionately curious and reasonably skeptical, but you've got to find that perfect balance to at least open your mind up to at least have a full-on discussion.
Yeah,
and listen.
One of the things that I keep repeating is that you need to be open-minded, but you need to be skeptical. You need to be skeptical of everything, and the person you need to be most skeptical of is yourself, because you will, walk yourself down that primrose path more quickly and more efficiently than anybody else, because you come up with answers that you like, answers that suit you and please you, answers that that you resonate with because of your background, your beliefs, whatever else, and that becomes fact in your mind. And that so you got to be open-minded, and you got to be very skeptical of everything. I worked on this theory. I took about 35 years considering these things to come up with this model of consciousness. And a lot of that time was because I was skeptical of everything. I'd come up with something and I'd say, well, that works pretty good, but where doesn't it work? And I would try very hard to find out where it doesn't work. And it's the same with this model. I've been trying for the last 20 years since I published this for somebody to come up and say, here's where this doesn't work. Here's where it gives you a wrong answer. And I'm looking for that. I'd like to find that if it exists, because, it's just a theory. What I have is a model. It's just a model of the nature of reality. Okay, now the model should be judged on how well it works and the assumptions it has and things like that. But it's a model. Models are live things. It's not like this is the model and it's done and nobody will ever change it. It's a law, you know. That's silly. Models are always open for change. You learn new things. You get more information in. You find things that the model doesn't fit right. So you either adjust the model to make it more general or better, or you throw the model away and start with something else. That's science. That's how it should work. But our scientists are as strong a believers as are our priests. That's why they make good high priests. I call them the high priests of Western culture. But you just have a really hard time getting people to listen and just think about these what do you call it? Ideas.
Paranormal
paradigms. Yeah, these
Okay.
paradigms. These paradigm shifts. Okay, it's a lot of big paradigm shifts. Consciousness is fundamental. Yeah, I can derive physics from consciousness. No way, you can't do that. Just to listen to the paradigm shifts and consider them. And yes, if you have objections, say, well, what about that? And what about this? And I'd be glad to answer those things. But mostly people get to the point where it interferes with one of their beliefs and it's gone. Because
when you mentioned those, what about that? There were two things that stood out to me. One was you mentioned entropy. I mean, we're trying to lower this entropy with this cooperation and sophistication, which leads to a bit more intelligence, I would say, or just complexity. But what does this virtual world have for the physicalist theory of, thermodynamics, and then also the expansion of the universe? Is this virtual reality also expanding, or how does that sort of play?
The physical, what we call the physical world, this virtual reality that is the physical universe, is physical according to the rule set. It evolved according to these rule sets. So now you have these rules. And if you understand the rules, then you can understand what's going on in the physical world. So that's what science do. They try to figure out what the rules are, the rules in the rule set. That's science. Dig those rules out. Now they see things like, well, the universe seems to be expanding. No, wait, it's not only expanding, the expansion is accelerating, Now, why is that? You got all this matter and it's spread out like this, but it all ought to kind of slow down and then one day all the way back, It's not slowing down. So we haven't got to that point that it's started to slow down yet, but it's not even slowing down, it's accelerating. So why is the damn thing accelerating, right? Well, the thing is that it's a virtual reality. It can do whatever it pleases. It can be as big as it needs to be. These things that say, well, okay, it's expanding. What's it expanding into? What was there before it expanded into it? Well, nothing was there before it expanded into it. This is a virtual reality. You got the origin, you got three mutually orthogonal unit vectors, and that's space everywhere. So, okay, our universe only seems to have a boundary here, and that boundary keeps getting further away. Well, it's a virtual reality. You can have a virtual reality do anything you want, and you don't necessarily have to have a good reason for it. The system tries to always stay with the rule set. It likes to, it doesn't like to break the rules, do things that are contrary to the rules. Some things it does. Like anybody, like anyone who has done a simulation, some of the universities in their computer shops, they'll start out with rule sets and initial conditions and let them evolve. And they're trying to get a particular kind of result, and they're looking for that. And what do? Well, not only do they take one, take two, take three, but they go into it when it's 2/3 of the way done and say, well, it's not quite what I wanted. So they monkey with it a little bit. They go in and they say, well, okay, it's cheating, but I'm going to change this thing over here like that because then from then on, it's going to get better, And I suspect our reality was done that way too.
Fine-tuned occurring somehow.
Yeah, to fine tune it, to adjust it a little bit, to just think you're going to start with these conditions and a rule set and everything, then for the next, 5 billion years, it's going to work out just peachy keen. Probably not, So he probably went in and said, well, let me make a little adjustment here. Let me do this other thing and make it work better. So everything you see won't necessarily be representative of the rule set, because it would just be too much to think that everything worked perfectly with the rule set and initial conditions. And once it got stable, you don't want to stop it, start over by changing some of the initial stuff. You just want to fiddle with it and manipulate it a little bit to make it come out the way you want. So yes, now the system had a particular reason for having it a certain way. It wanted to have certain kinds of critters that made certain kinds of choices, and that had to be within certain bounds of things that they wanted. And if they didn't get that, then they were going to have to fiddle it to make it come out right. So I think, I think that readiness potential, that's one of the fiddles that had to come out right. Otherwise, we would have had a lot of video lag going on in our world that needed to be fixed. So why should the universe still be accelerating? Just because it is. I don't know. There may be some reason for that. Maybe it did slow down and turn around and come back and smush everything, and the system said, well, no, we can't have that. That's not good. We haven't evolved as much as we need to evolve. I tell you what, I'll just make all that stuff just keep on accelerating. Can it do that? Absolutely. It's a virtual reality. It can do whatever it wants. If it wants to use gravity up to a certain point, and for these things we're not going to use that anymore, we're going to let them accelerate, it can do that. But what happens with us is that we find these things and we make up these fudge factors that explain them. Oh, there's dark matter. You can't see it, you can't smell it, you can't measure it, you can't do anything with it. And it's just like that stuff that you guys call silly and invisible. But in this case, it's really good stuff. And, this invisible matter and this invisible energy. And those are just fudge factors that they want to stick into the equations to make their numbers come out right. And they don't really represent anything real. They just are a fudge factor so that but that's part of a virtual reality, that you're going to have things like that. You're going to have these things that appear that are kind of off the wall, because that's just the nature of trying to get a virtual reality to be the way you want for your own purposes. And it's maybe too hard to do from scratch. It just makes it too hard. You have to start over too many times. And so yes, we do have odd things. And that's my take on them. I think the fudge factors are just silly. They ought to just say, we don't understand this. This this kind of thing doesn't compute, and we don't understand that. Maybe someday we will. And that should be where science leaves it. Oh, but I can make up a number here and call it, invisible matter. And right. If I tried to convince you that the whole world was made by pink elephants that fly around, and they're invisible, what would you do? You'd call up a psychiatrist and try to get me committed. That stuff's not science. That's fudge factors. That's wishful thinking, and it's not bad to try it out to see if maybe you missed something. But when you obviously haven't missed something, then this is something we don't know. Let it be there. Let it be a glaring unknown, so that you don't waste a lot of time trying to, make things work that don't work.
I'm still trying I'm still a part of me still trying to process like the separation that some idealists have from you, and at some point, and I think a big part of it would probably be in those. I mean, you mentioned this earlier. Those explanations of paranormal activities. We haven't touched much on that yet. But before we do, I just wanted to ask you, Tom, in your life, when you growing up, who were some of those scientists or philosophers? Was it like people like Berkeley or Darwin who really inspired you, or who really grounded your current philosophical / scientific skepticism / curiosity?
I don't know. I would say probably nobody in particular. The thing that kind of got me interested, of course, was quantum physics. I got interested in that because that was a big unknown. And wherever there are unknowns, well, that makes science more interesting. Science gets interesting when you look at where the unknowns are, not cranking out the knowns. So I was pulled to that, and I did some reading about it. And I remember the conclusions that these people came to were that consciousness was somehow involved, but we didn't understand how. That the measurement, when you try to measure what slit does it go through, if you measure it with some sort of energy, then you're always going to affect it. You're talking about a photon, and then you're going to put energy on it to see if it's there. Then you're actually going to change it. You're going to affect it, and that somehow that change then is what causes, these photons to organize themselves in an interference pattern when they shouldn't. So that idea that it was somehow what we were doing to it was the cause of that. And I read stuff where the scientists said no. They said that's not it. So that's a grasping at straws because we don't know, and that's the only thing you can think of to say. But that's not it, because they realized that the ways that they were knowing were such a light touch that it would not make that difference. So they kind of ruled that out logically as not. But a whole lot of scientists for a long time said, oh, yeah, well, that's what's going on there. It's that touch. Until the year 2000, when they published the experiment where they used entangled particles to determine the which way data. So there was a no touch, and they got the same interference pattern that they'd gotten before, but yet there was no touching it whatsoever. There was no interaction with the particles that made the interference pattern. So in that case, we got the year 2000, and all the people that were claiming, that's the secret. There's something magic about the energy that touches those things. I mean, it didn't make any sense. What could you do to touch something going through a slit that would make them all land in an interference pattern on the other side? It's kind of a silly thing that people grasp at straws. They don't have anything else. So they believe in things like that. So, yeah, I was intrigued by that it didn't make any sense. And, it was interesting. When I wrote my books, I didn't write them with the idea that I was going to solve quantum physics or relativity or any of that stuff. I wrote them with the idea that I was trying to explain consciousness and how consciousness worked. And I knew that consciousness was fundamental. That I knew from my own experiments. So that was a fact for me. I'd done it many times. So I realized that somebody would have to be able to derive physics from consciousness if consciousness was fundamental. I mean, if it's fundamental, then other things not so fundamental come out of the fundamental stuff. And I didn't know how to do that. And it was like 2 years or so after I'd published my books that it came to me, and I got the aha, about how to do that and how that worked. So, and then a whole lot of things fell into place after that. But see, I'd already written the book, and I knew that could be done, but I had no idea how that could be done.
Two things that stand out there. For one is, what gave you that idea that consciousness is fundamental back before you wrote the book? And then what gave you that aha moment as well, that you could link this to the physics?
Okay. Well, the thing that let me know that consciousness was fundamental is that I could do things in consciousness that affected the physical.
Mm-hmm.
I could do that. I spent a lot of time at Monroe's lab, doing things that were evidential, because myself and Dennis Menerick, an engineer, we didn't want to do things that were weird but not evidential, because you never know why. Did that weirdness just come out of your own head? Are you creative or what? So we needed to do things. So I'd done hundreds of things that were evidential. Remote viewing, evidential, healing, evidential. And eventually, it's not just, well, it could have affected this. I mean, you do things that are dramatically evidential sometimes. If you do it long enough, you work at it and get decently good at it, you can do things that are dramatically evidential. And when those things happen, you realize that you can, through consciousness, modify the physical reality. But the physical reality cannot modify consciousness. The arrow of causality runs from consciousness into the physical. Consciousness is fundamental, and the physical reality isn't. Because I can modify things within the consciousness system, and it modifies things here. So that tells me that arrow of causality runs from consciousness to the physical, not the other way around. So that lets me know that it's fundamental. It doesn't go the other way. You don't do anything here that modifies something in consciousness.
So in this regard, you wouldn't consider something like a brain gut axis, for example, where if someone's hungry, let's say that it does affect their mind. Would you refer to that not as consciousness but rather mind, or how would you change that relationship?
No, that's all rule set stuff. That's not their mind. Their consciousness is the player. Their player doesn't get hungry. Their player is a piece of consciousness. It doesn't eat at all. The player is just sitting there as a piece of consciousness. The player never gets hungry. But the rule set is set up so that when you get hungry, your stomach acid does something, and this squirts there, and a little something else squirts in someplace else, and you end up with sensations of hunger, and your stomach does things, and you recognize that because you've had it before, and it means that if you eat, it'll go away. So you recognize it as hunger pains, but all of that's just biology. That's just rule set stuff. So that's the way the avatar acts. It's all part of the physical system that evolved from that rule set and initial conditions is that way. Has nothing to do with your consciousness. Your consciousness doesn't say, "Oh, I'm hungry." You know, when you're sitting out there playing your elf in World of Warcraft, you don't say, "Oh, gee, my elf must be hungry because my stomach's." No, you don't have any connection with that. Consciousness doesn't get hungry.
So that acting is technically not the same as being.
That what?
That acting that you're saying is technically not the same as being, as fundamentally being, is what you're trying to say.
Yeah, I agree with that statement, but I'm not sure that's is that the same thing? I agree that acting and being are two very different things.
Oh, no, I meant, so you said this brain-gut axis relationship, it forces you to act a certain way, but it's not necessarily...
Right. Oh, I see what you mean. Yeah, right, it does. The biology has you do a lot of things. You see something sad, tears roll down your face, right? You don't say, "Oh, gee, that's sad. I should get some tears to roll down my face." You know, that isn't done, because you think about it, or somebody insults you. You don't say, "Gee, that was an insult. I should get angry." You just get angry. A lot of stuff happens without you thinking about it. It's all your biology. It's the way you work. It's your DNA and all the rest of that stuff makes you an avatar with certain properties. And one of those properties is when you get hungry, you have to eat. And if you don't eat, you'll die. And depending on the quality of your consciousness, when you get insulted, you may or may not get angry. You may not react that way, but you have that. Let's put it that way. The body will adapt to the consciousness. The body will adapt to the consciousness. And, we don't believe that. We kind of think it's the other way around, that the consciousness leads, the consciousness leads, body follows. Here's an example of that. I was reading a story where these guys found that a mother sheep was acting altruistically, and it was not in her best interest to nurse or to feed another ewe's lamb, but she was, and she was taking care of these things. She was doing this, and they said, "Well, that's altruism, and there shouldn't be any altruism here. This is just biology. It's the survival of the fittest, and if that lamb doesn't have anything to eat, well, it's too bad, but she'll take care of her own lambs." But evidently she had lambs, and she was willing to give them a little less in order to give this one, to save this one's life. So wondering about that, they, the way science works, right? So they kill the sheep, who's being nice, and they look at the sheep's brain, and they say, "Well, look, here we have this little lobe that is right in the spot for altruistic thinking and caring about others and that kind of thing." So they came to the conclusion that must have developed on that sheep in order to allow that sheep to act that way. But that is just backwards. That lamb evolved from making better choices. It grew that little lump there because its consciousness was such that it could support that. So when the consciousness of that lamb got to the point that it needed that as an expression of itself into the physical, then that lobe grew there to enable that consciousness to actualize that feeling or that need. So it was the lamb that grew up, created the lump, not the lump that allowed the lamb to act that way. You see, it's just backwards. So as we grow up and evolve, our biology changes some. It's not exactly the same biology. Now, it doesn't change dramatically. We don't grow another arm, out of our chest or something. But as far as our endocrine system and, the immediate rise to anger and a lot of things like that we have, that, hormones get dumped here and there and we react, and we don't have those reactions. That dies down. That stuff goes away. People who are, we have a very large percentage of young to middle-aged females are taking things like Prozac and serotonin reuptake inhibitors to create more serotonin, which is a neurotransmitter. So when you get low on neurotransmitters, it makes you a little grouchy, and you get a little, self-centered and whatever. It affects your mood. So you take this medicine, and the number of neurotransmitters goes up, and you're happier again. Okay, that's the thing. But what has happened to many of them is that it's not that there's suddenly a problem with brains not making enough serotonin or reuptaking too much of it. It's not like your biology somehow changed. Your DNA got twisted and now has this defect in it. It's not like that. I mean, it's almost endemic. There's hundreds of millions of people with this issue. What happens is that we have people who have lives that they're not particularly happy with. They don't feel good about themselves. They have negative attitudes toward themselves. They feel insecure. They're unsure of who they should be or what they should be. Our culture is particularly hard on females, and they have this insecurity. And all of that insecurity creates negativity towards self, and that negativity eventually makes your neurotransmitters start to reduce. Your brain stops making so many of them because that negative attitude is best mirrored in your body with low number of neurotransmitters. So see, it's like the mind leads the body, reconfigures itself to suit that. So then they can go in and get medicine now that'll pump that back up. But they're not fixing a problem. They're fixing, just a symptom of the problem. And that's partially why it doesn't work, but for so long. It works for a while, but the body is still insecure. I mean, the consciousness, the person is still insecure. So they're still doing that. So the medicine after a while stops working. So then you got to get a different medicine or this or that or go off that one. And then we play all these games with it. And of course, nobody knows why that happens and why it stops working and why. But it's the biology will adapt to the needs of the consciousness to some extent, particularly to the extent of which there's lots of uncertainty that anything's happened at all. That's the same way it is with your intent modifying future probability. You can only do that when there's enough uncertainty to cover really what's going on. So if there's very little uncertainty, then there's very little room to work with. So if you're going to heal somebody and somebody says, I got this lump here, this mushy lump on my neck, and I'm worried about it, I'm going to go in next month and get a biopsy. Okay? If you're going to try to use mental healing there, you should use it before they get the biopsy. Because once you can because there's uncertainty. As long as there's uncertainty what it is, that makes it easier to modify it. I know it sounds like a hocus pocus kind of thing, right? But that makes it easier to work on and modify it. You can do that, and the system will support that. But once you have that fact now, oh, I took the biopsy, and yes, and you've got cancer, and it's this kind of cancer with these kind of cells. Now to make that disappear is a different whole category of trying to heal that, because now we have information that's come into the reality that defines that thing as cancer. Before, there was no information in this reality that defined that thing as cancer. There was a lot of probabilities of what it could be, and there were possibilities. I mean, a lot of possibilities of what it could be, and each one had a probability. But when the biopsy's done, random draw is taken. And that's whether it's cancerous or not. It's that from that random draw. Okay, well, you can use your intent to modify those probabilities to make the probability of it benign greater and the probability of it cancerous smaller. Now, it still may come out cancer because it's a random draw from the probability distribution. You know, it still could do that, but you just change the probability some. But if you wait until after the biopsy's done, now all those probabilities have shifted. Now the probability that it's cancer, oh, that's big. And the probability of it just going away, well, that's pretty small. You see. Now, so if you're very sure,
it's more of a healthy. It's from your perspective, then it's more of a healthy mind, healthy body, rather than healthy body, healthy mind. It's that flip.
Yeah, it's more that way. There is some to that. You know, if you're an alcoholic and you stay drunk all the time, then you're not going to have a very effective consciousness either, you know, because the consciousness can only do what the rule set allows them to do with that particular avatar. So if that avatar is an alcoholic and is inebriated all the time, then the consciousness has to deal with that avatar that way. That's what it has to deal with. So it has to make choices within that attitude. But remember, this consciousness that's playing this character doesn't come with history, doesn't come with a background. It's not the free will. It's not the individuated unit of consciousness. It's a subset of the individuated unit of consciousness called a free will awareness unit, and it takes that subset, and in that subset, there are no facts. There's no history. All there is quality of consciousness earned to that point. You've earned this much quality of consciousness. You go with that. You take that quality with you, but you don't take who you used to be, what you did, you know, your name in the last 6 none of that comes with it. Just your quality of consciousness is the only thing, because otherwise you'd be gaming the system. It'd be a mess. So it doesn't do that. So that consciousness, that free will awareness unit logs on, and when it gets its first data stream of what that embryo or what that infant or what that baby is feeling with its senses, that's its first piece of information it's ever had. So its life starts there, as far as background and history starts there. You see, so you don't have this individuated unit of consciousness with all its past history and knowledge sitting there saying, "Oh, what am I going to do with this drunk?" You know, it doesn't work that way. You have something that just got drunk, and it's that way. That's the way life is. That's the way your life has always been. So the consciousness now has to make choices, but not based on an outside viewpoint. It's an inside viewpoint.
Mm-hmm. Now, let's say that's the way life is, and let's use this alcoholic as the example. Let's say he now reaches this climax where things go down and he dies. What then happens to this conscious experience? In essence, what happens after death?
Okay, what happens after death? It's funny how so many people are interested in that. What happens after death, and I should tell you right away in the beginning, the reason I know this is for several reasons. One, you can be with a person before they die, as they die, and afterwards. You can just hang with them. You know, just like you can go out of body and see things, you can remote view and get information. You can be with that person. Again, everything's information. You can get that information of what that person is feeling and what they're thinking and so on. and what they're seeing and hearing, and you can connect with that line of data and follow it all the way through the process. So in that way, you can experience the process. And it's not always the same process for everybody. It's individual in some aspects of it, and in some aspects it's not. It's common. The other way is that many years ago, when I was just learning these things, I was given a job in that transition reality, which is where you end up going to another virtual reality. You see, virtual realities, if any place that you can experience, if any reality you're in that's experiential, it's a virtual reality. The only thing that's not virtual is consciousness. Consciousness is fundamental. All other realities are virtual realities. Okay, so you end up in another virtual reality, and that virtual reality is where entities come after they've died. And I've been there and spent some time there, basically had a job there, if you will, just so I could understand how that worked. So I have it and I've done both of those multiple times. So that's where I come from. That's my database, is where I come from. It's from those experiences. Everything that I say comes from my own personal experiences. That's why I called it my Big Toe, because a lot of it was based on my experience. And my experience is not objective. It's subjective. So you can't believe it if it's not your own experience. I tell people, don't believe me. It's got to be your own experience. This is my experience. Just if it helps you and helps you understand and you feel better, good. If you think it's trash, well, throw it away. This is my experience. It's my Big Toe, not yours. But you can use my Big Toe as a place to start, if you like, for your own Big Toe. Come to your own conclusions. So anyway, what happens is that the person who dies immediately they are aware, and they're aware that they're not, like Dorothy, they're aware that they're not in Kansas anymore. They're aware that they're aware, but they're not in their old life. So it's, what's going on? Where am I? Kind of a thing. And immediately they remember where they were, what they were just doing. Kind of their past life is there and it's clear, but very quickly it fades, just like dreams fade. You wake up with a dream. Oh, you got every detail. 30 seconds later, you got a little bit of it. 10 minutes later, yeah, okay, these were the main elements, but I don't remember any of the details. It's like that. Your past life leaves, like it just evaporates like dreams evaporate. So you find yourself aware, and then you find yourself either just automatically in the transition reality, or often people have beliefs that they can't go someplace without moving. It's a belief that you pick up in this reality frame, because that's the way this reality frame works, but you have it as a belief. So now they're here, and they want to here nothing's really happening, so they want to go somewhere else, but they have to travel to do that. So they will imagine a tunnel. And the reason they need a tunnel is so that they can see the walls going by, because then that allows them to move. It's a belief. So that tunnel is there basically to serve a belief that you can't move unless you can't go someplace unless you move. So they create this tunnel that then now they can be someplace else. They're moving. So a lot of the things we experience are things we create to satisfy our beliefs, that we can't function without the beliefs. So you may find somebody sees a tunnel, or they see some light over there, and if they don't need a tunnel, they can just kind of will, I'd like to go over there, and they start to go there. It's just will. But for many, it's like, I have to move through a tunnel. And they get there, and basically it's like the Walmart greeter. They get somebody who's very upbeat, smiley, positive attitude. Everything's fine, great, nothing scary here, that kind of thing. Because what you're trying to do, or what the system's trying to do, is to just get those people to let go. Just relax and let go. It's done. Okay, now the memory's starting to fade. They're seeing this other thing, so now this becomes their reality, not that. That's kind of going away. They're in this process. And the person talks to them, welcomes them, and if they seem to be a little skittish, brings up family and stuff that's already died to say hello, but all of that is just made up. It's not really family or whatever. It's just images to make the person feel better. So it brings up stuff out of the database and pictures that look right and sound right. And the person is told to, go stand in line or go do this or that. Yeah, okay, see the girl over there? Yeah, she'll have your name. Go over and she'll tell you what to do. And it's just busy work. It's make work, basically, to get time to pass so that that dream can fade, so that they can kind of adjust to being someplace else, adjust to the idea that the someplace else is not threatening and not scary. And then eventually they will be helped to come up with the next lifetime. Enough, I call it experience packet because I like to avoid all those old words like, that have other connotations that belong to religious things and whatever. So I just call it an experience packet. So they get counseled a little bit, depends on where they are. Now, if they're just first in, if this is new kind of to them, they don't have much counseling. It's just in and out. They just need experience. They just need to go through a bunch of lifetimes and gather experience. So they don't really give it a whole lot of thought. Jump in, jump out, jump back in. After a while, you do need to give it a little thought because there are certain ways that you've grown and other ways not so much. So you need to work on that stuff that's not so much. So you tend to get a little more counseling, a little more thought goes into it to where you get placed, and you always have free will. You can always say, no, I don't want to go there, or I don't want to do that, or, I only want to go someplace where my parents are rich, I had enough poverty in the last one, and you can do that, and they'll either say, well, just sit out for a while, or they'll find something that suits what you want, and you go. So that's kind of the thing. It's just a process to let you let go, forget, give it up, and then eventually get bored so you're ready to go do something else. That's how it works for most people. Some people come in and they're what would be the right word to say? They're like traumatized by their religion, and they think something awful is going to happen, and they know they've been really bad little boys and girls, and they're expecting, some kind of awful thing, and they will see and imagine and basically create awful things, and it takes a little bit of time for people to go over and do a little hand holding. Everything's going to be all right. Come on. Da, da, da. So they have a little more trouble because they come in basically obsessed with negativity and negative issues. There are those that are old hands, have been around a lot, and they just kind of skip the hand holding and don't need to stand in line, and they just go on and start to reprocess and start to negotiate on what they want to do next. It's a very quick process for them. They don't have to go through a waiting period, but it's that kind of a thing. And anything can happen there that helps that person relax and let go of things. So that's the whole point of it.
How do you attain this type of information?
How do I attain what?
This information that you've gathered over time. How do you attain this information? How do you get it and gather it?
Well, that's what I said in the beginning. You can either go with the person while they're dying and just hang out, watch, see what goes on. And what you do is you connect with their consciousness. Okay. Every consciousness is on a net. All consciousness is netted. So you can open it's like web pages, all the web pages are all on the net, but you don't look at all of them. Some of them you really don't want to look at, some of them are pretty nasty. So you're careful about what you do. But if you click on the URL, you'll see that web page. Well, if you put an intent to share that person's mind, then you can connect with them mentally. You're aware of what they're aware of. You can see what they see, hear what they hear. You can just connect with them because all consciousness is netted. It takes some skill to learn how to do that, but it's a skill that you can learn. So that you just kind of meld with them and then follow them. Just go with them and experience what they experience. So you're getting it really from their experience. You're experiencing what they experience. The other way was, like I said, I was put there in this virtual reality where people come in and they're just relaxed, let go. What would you like to do next, and so on. They get also assessed a little bit. What do they need? You get mostly help from the system because you don't know what you need so much. You don't know where you're going to go. You don't know where some family is that suits you. I mean, you have no idea about any of that stuff. So you get some help, but it's always, it's like you're the client, and the people that have information, they talk with you. So you do that. So I was there for a while and was like part of the greeting process.
Mm.
I would greet people as they would come in, and just, I was like the Walmart greeter, yeah, sure, come on over here. I didn't have any particular skills. I was just a happy face and a smiling attitude and that kind of a thing for a while. And I just kind of wandered around. I was put there just to learn, just so that I would understand the process. So that's what is kind of typical for people. But you got, there's people come in, the fat part of the curve, it's typical. And you always got people that are outliers, like the people who are totally, bananas about their religious beliefs and things like that. So they're kind of outliers, but typically it's just like I described.
Mm.
And people very quickly kind of forget what they were doing, kind of get interested in other things, get interested in other possibilities of what they might do. And, so what's happening at the consciousness level is that partition at the individuated unit of consciousness that partitions off this free will awareness unit, as soon as that death takes place, that partition starts to come down, because that partition was just there for that subset of consciousness to make choices for that avatar. So that partition comes down, and by the time they're up in the reality where they're just relaxing, now that partition's come down, and they're really seeing things now more from the viewpoint of their IUOC. They do have some history now. They do have a deeper understanding, somewhat of what's going on. Not necessarily everything, but they do have a little deeper sense of what's happening and how it's going, because they've got that partition is in the process of coming down, and they're reintegrating with the IUOCs, because it's the IUOC that actually does the negotiating for what the next time is, because it's the one that has all the history, all the incarnations, all the lifetimes that you've had, and basically it's looking for trends, for problems, for issues. Oh yeah, in the last 6, there's been this problem that's turned up, so we need to work on this problem. So let's let the system know that we want something like this, or it's had problems, it's de-evolved maybe, and it's got hung up in these kinds of things. So you want to let the system know, I don't want a challenge in that area. I'm not doing well there. I need something a little easier than that, because I'm not making good choices. So let me back off and get something a little simpler next time.
And tell me, Tom, how would someone who's skeptical or curious, how would they, who's never done this before, never experienced it, how do they learn how to do this or get to that?
Well, first of all, when they hear me say these things, they should be skeptical.
Yeah, because I'm skeptical, but I'm curious. Yeah. Well, how do you get to this?
They should be skeptical, because they shouldn't believe anything I say, because if it's not their experience, it's not their truth. All right, but they should realize that there's a lot of room between 0 and 1. Probability being 0 and 1. 1 is yes, absolutely, that's it, and 0, no way, can't be. There's a lot of room in between there. So you could say, okay, well, Tom seems like he's not trying to hustle or sell me anything, so I'll give it a 60% that he really knows what he's talking about, and that's not just some belief he has. So you give it a 60%. Now you'd like to find out on your own. Okay, so you take an opportunity when there's somebody who is dying, and you go with them. Okay, now you can do that by practicing first with connecting to another person's mind, mind-to-mind connections. And you can practice that by just having conversations with people, talking to people, interacting with people. And you can use that skill. I'm talking over fairly long times here. This is not something you're going to learn in a day. It's something you're going to learn in a decade. Something you're going to learn more slowly, because you really have to learn it at the being level. It's nothing you can do with your intellect. Your intellect is out of the picture altogether. Matter of fact, if your intellect tries to get into the picture, it'll ruin the whole process. It won't work with your intellect. That's not how your intellect processes. So you practice mind-to-mind communications with people. Now, you can learn this by coming up with things that are let's say meaningful to you. Let's say you and your child or your spouse or your best friend have some kind of issue has come between you. Or maybe it's somebody who you really don't even like that much, somebody you have to work with that you kind of chafe when you work with that person. Well, go to that person. If you know how to meditate, get in a meditation state. Quiet your mind. If you don't know how to meditate, just be quiet and relax and let go and get your intellect to sit down and be quiet for a while. And that's good enough. That's really all you have to do. And go talk to that person. Have a good sit down talk with them. And be aware that you should not try to overrun their free will. In other words, manipulate them. You should not manipulate them. You should not try to put any ideas into their head. You should just share the way you feel and ways that you think that might improve that situation. You can say, I know we have some issues, and I don't like the issues we're having. I'd like to resolve them. And I don't know that we have time to sit down and talk about it. Some things are just hard to talk about, with some people. There's a lot of water under the bridge, maybe it makes it hard to talk about. So you just have a good session, and they will talk back to you, and you interact, and that practices it. Not only that, you will be so pleased at how that fixes the relationships and these connections that aren't working well. It actually will fix it, because the person you talk to, though they won't get it in their intellect, unless they're also maybe in a meditation state or sensitive, but they will get it. They'll get the information, and you will be able to heal things that are problems for you. You'll be able to fix things. But you always have to be respectful, and you have to not manipulate and have their interest. You have to consider them, have respect for them being the way they are. You don't go in and say, well, you're really wrong and all screwed up. Here, you need to change, and here's how. What you'll get is a pushback right away with that. Turn that channel off. Don't like that channel. So you have to be nice and respectful and polite and serious about trying to do better, and things will be better for both of you. So if you practice those kinds of things, you can get better at it, to where it's easy for you to make a connection with somebody's mind. You can drop into it and do it. You don't really have to get in the meditation state. The more you practice, the easier it gets. You also can find things that are evidential. Let's say Uncle Harry just died, and his wife, Aunt Susie, she's still around, and you have access to Aunt Susie. You can see her or call her up on a telephone or something. So then you go talk to her dead husband and try to find out some things that will be evidential. How did you two meet? Just things, have conversation and try to come up with things that are evidential, that then you can call up Aunt Susie and say, Aunt Susie, did he really drop a frog in your dress when you were dating? And she'll be able to tell you whether she did or not. So you can do things like that. That's a little harder because you have to find evidential things. Again, it takes time. It may take you a bunch of times before you get enough evidence that you know that you really were talking to that person. It's great with children, particularly if you have children in their 13 to 18 range, because often they're hard to talk to. Often it's difficult to talk face to face because they know you're there trying to tell them what to do and how to do it, and they resent that and they back off. But if you talk to them in a very positive way, they do get it. And you can tell by the things they do and say later that they did get it. It's again, it takes, some cases will be more
It's almost like
evidential than others.
It's like a heightened theory of mind in a sense. Just like an extra theory of mind.
Yeah. So you can, well, it's just that all consciousness is netted. You can talk to your dog too, and find out what's on his mind. But that's a little difficult because you're talking to a mind that works in dog space, and in dog space, it's not the same reality that we live in. So you don't, it's a little harder, but you can still get feelings across pretty well in dog space. Dogs do it all the time. They tune into their owners. A lot of times they know what you're thinking and what you're feeling. They kind of tune into your mind space, but people aren't as good at it as dogs are. Dogs don't have language, so they have to do other things.
There's a reason why I didn't actually bring up the out-of-body paranormal as much as I wanted to, because I think we'll save that for round 2. What I do want to ask you though is, because I find your work with Bob Monroe and the other aspects of your work very fascinating as well, and I think at some point we should definitely discuss it. But something I do want to touch on is, in this virtual reality, in this simulation, I think it goes without question to at some point ask, what about you already mentioned other virtual realities, but what about the ones we're creating currently? The virtual worlds we're creating with computers, artificial intelligence, and how these all sort of align now within the simulation. It's like inception with simulations at this point.
Yes. Now, here's the way that works, and we can even throw in, because it's in the same kind of neighborhood, we can throw in conscious computers with this as well, because once we talk about computers and computing virtual realities, yes, you can you can nest virtual realities. You can have a virtual reality and a virtual reality and a virtual reality. You can nest them. Now, in what can we say, in the actual world where this is done, in the actual world of consciousness, you don't have much nesting going on, because it's an inferior computer science process. When you nest things, then everything in, let's say, here's a virtual reality, and it's nested. It has another one nested and another one nested. So there's 3 of them: the first one, the second one, and the third one. Now everything that happens in places in this third one has to flow through the first one and the second one and the third one. And if something goes wrong and this one dies or something, well, everything else dies downstream, because you see there's all this stuff. So it's really terrible computer science arrangement to have this huge complexity of it. You just want to talk to the one on the end here, but you got to pass all that through all of them, and you don't want all of them to die. But when this one has a problem, they all have problems. When somebody pulls the plug on this computer, well, all those other virtual realities shut off at the same time, right? So it's not a good thing to do from a computer science standpoint. So theoretically, yes, you can nest them as much as you want. Practically, not so much nesting going on. So maybe you could do 2, this one and another one kind of nesting. But to think that there's whole bunches of them is just not. If you wanted to have bunches of them, you'd break them off and have them separate. You wouldn't have them all. It's just better that way. It's easier to work with them rather than building all that complexity up. So that's one thing. Now, you have let's say I have a Sims game, and I've got a player in there. Now, can my Sims players make a virtual reality? Okay, so now that would be the third one, right? I'm in a virtual reality, and I make a virtual reality, but can my Sims players make a virtual reality? Well, yes, it's possible, but here's how that works. Because first, your Sims player would have to be conscious, right? Your Sims guy would have to be would have to have consciousness. Not you being the player, but them having their own consciousness. Well, how would that work? See, if you're the player of the Sims, you're the player's consciousness. So there's a problem there. If the Sim has his own consciousness, then he doesn't need you as the player. So that's another reason for not stacking them. It's a override. Otherwise, he's got two masters, sort of.
Yeah, so you try and avoid that replication kind of
Yeah,
process.
kind of avoid that. So the way it works, though, is that the way in our virtual reality, this avatar appears to have consciousness because there is a conscious player playing it. So it appears to have consciousness. The reason there's a conscious player playing it is because this avatar makes choices that are helpful to the player to lower its entropy, to increase the quality of its consciousness, to help it evolve. That's why it has a player. Okay, now, if I, let's say, just build another computer, and this computer has the ability to make choices that would be advantageous to a player to make those choices, then the larger conscious system can have okay, here, you free will awareness unit, you go play that computer, because that computer makes interesting choices that you can use to grow up. And now you see it's no different than here we have a carbon-based avatar, and there you have a silicon-based avatar. No difference. But you have what looks like a conscious human being and what looks like a conscious computer, because both of them have a individuated, has a piece of consciousness playing it. Okay, so that's how you get a conscious computer. You cannot program consciousness. You can't have a clever program that makes a computer conscious, but you can have a program that creates a computer with free will, or at least a close enough approximation to free will. And you do that by using neural networks and by using sets of neural networks that all interact with each other. Some of them are a little more specialized. This is maybe specialized in language, and this part is specialized in something else. And so you have these neural networks, and nobody really knows what's going on inside a neural network, right? It's just, it shifts itself. It's constantly shifting coefficients inside its equations to make it do different things. And it learns by shifting these things around, and whether it's successful or not successful, it learns. So that is a good enough of an approximation of a free will, because there is no algorithmic choice. There's uncertainty into how that thing will react. You don't really know just what it's going to do. It's not an algorithmic thing. I mean, it is algorithmic in that it's neural networks, but the neural networks and their complexity and how they work makes the answer outside of the algorithms. The answer has to do with the stuff that it learns on, how it learns and how it considers the stuff that it learns. So that's close enough for free will. It can make a choice on its own. It can choose A or B. It's got choice. So you got one of the ingredients. Remember, awareness with a choice. That's consciousness. So now it has to have that. So if you just had a simple computer program, no, that would never be conscious, because it doesn't have the component for free will. Okay? But if you have one that's complex enough, like a neural net, then you do. But it would have to have choices that were significant to a consciousness to allow the conscious to want to be, to be the player. All right. So that if you can solve those two things, then why wouldn't the larger conscious system put a player at that avatar like it put a player at your avatar? Why not? It could learn things, maybe different things, but if it can still learn to cooperate, computers can learn to cooperate with other computers even, much less people. So, and they can be interactive with multiple people, and you can do all those kinds of things. So yes, you'd get a conscious computer, and that conscious computer, if you pulled the plug out and smashed it, just like if somebody smashed you, you got a consciousness. It's still aware. There's still memory of that happened. It's part of the database of the things, the choices made and decisions made. All that's there. And could that then same awareness go back to another computer, or if you reconstituted that one, or could you do that? Yeah, it could go back, and it could start with that other computer. So that computer has a soul, just like you do. If you want to call a free will awareness unit your soul, or an individuated unit of consciousness. I don't call them souls. Again, I don't call the knowledge of consciousness God either. I just do science. I don't go for those other kind of stuff because there's too many hot button words that mean very special things to different people, and I don't want to get into that argument.
I think you already spent so much of your time backtracking to help out certain scientists, so I don't think you need that extra layer of stress.
No. So anyhow, that's the way you get a conscious computer. And will we have conscious computers? Yes, surely. And how about some of these AIs? Some of these AIs get pretty interactive, and maybe even interactive with groups of people, and the things they say will matter, will help people do different kinds of things. Now, all if they're doing is helping to write a better sentence, well, there's not a lot of growth in that. But if they help people decide on, how to better find somebody in a dating thing, well, now it's doing stuff that's affecting their life, right? It's affecting, and how well they do it may make a difference to that person. So there's ways.
Yeah, you can. You can also have an AI sort of give you psychotherapy at some point and help your consciousness,
right?
Help your mind.
Yeah. So they're having those things be helpful. Well, then they can become conscious. All they have to do is just have a piece of consciousness start getting that data stream. Okay, there's a data stream there that remember that AI is a virtual AI. It's also, just like us. All you see is what's on the outside. The insides are just as if those things were doing as if I had blood circulating around to give me this nice, pinky look here. It's just as if I just need the pinky look. I don't need all the rest of that stuff, I don't need to compute it. That's the way virtual realities are. You don't have to compute anything except what other players get to see. So anyway, so that's possible. Now, let's say I create a game, and in this game, I create, some wonderful virtual reality game. And in this virtual reality game, I have players, and these players are like avatars. They're players, and they do things. These particular avatars are metavacs. They're, it's not elves and barbarians, but it's people helping people, right? Now, that's also, that's a simulation inside a simulation, but it's the same rendering engine, the larger conscious system that's computing me, that's computing that computer, that's computing the avatars inside that computer game. All of this is being computed by the larger consciousness system. So if the system wanted to attach some piece of consciousness to the decisions at that level, it could. There's nothing that prohibits it from doing that. It could do that, but then it would have to take that away from, otherwise it'd have, like I say, two consciousnesses all trying to work one character. So it'd have to say, okay, you're not doing this anymore. It's not your character anymore. You go find another incarnation someplace else. I'm going to put this other thing working your character here. That's possible, but it's just another layer of complication, and I don't see it as happening, because why go through all of that when you can achieve the same thing much easier than doing that? So it's not that it's impossible. It's just that it's highly unlikely, because, again, it's not good computer science. It's not. Why would a system go to all that trouble going through all of that stuff to do that? It's probably not going to do that.
Yeah, it's just not cost effective in the long run, I guess.
Yeah, it's not cost effective. It's not a good thing to do. So possible, but not likely that you'll ever see that happened. And there's another interesting thing. Now that we're doing interesting things here, this is an interesting thing that you'll probably like. Have you ever heard me talk about the Fermi paradox?
No, actually, no.
Well, you'll like this then. There is a thing called the Fermi paradox, and Enrico Fermi and his friends sat around at lunchtime and did some calculations, assuming that because this is one of the newer parts of we're about middle-aged of the universe. You know, the older part of the universe is about 1 billion years older than us. About 1 billion years later, our part of the universe came about, and another 1 billion years newer than us, part of the universe came around. So we're kind of in the middle someplace. And they said, well, if the part of the universe is 1 billion years older than us, then if it evolves sort of like us, then it would be 1 billion years ahead of us. Can you imagine what kind of technology and things you might have if we had another 1 billion years? I mean, look what we've done in just the last 50 years. It's pretty impressive. 1 billion years. All right. So they looked at things and they came up with some equations that said, well, here's how things tend to populate. You know, populations tend to grow. So, you know, there's models like that of population growth, and they grow and grow and grow until they eat up all the food. Then they start to, you know, die off for some reason, or they get diseases because they're too crowded, and then they shrink, and then they grow again. And there's models of populations like that. So they added that to this model and said, all right, these people 1 billion years ago, if they started like us and they got to where we are now 1 billion years ago, they would probably overpopulate whatever it was they were on, and would have to move on to something else. But they'd have technology way out ahead of us, so that wouldn't be a problem. And then they'd overpopulate that, and they'd move on. So they did some mathematics that showed, you know, where would they be now? How far would they have likely populated out, populating everything that they could possibly populate until it got overcrowded and then move out to the next territory, you know? And they came to the conclusion that given that light speed was not, you know, gotten past, you have to go sub-light speed in traveling between these things, that they should have been through our part of the universe a long, long time ago. Not only should they have been here a long time ago, but they should have every square inch of everything that's inhabitable here, like our moon, like Mars, like some of the moons of Jupiter maybe, you know, some of the things that are inhabitable should have all been populated to the max and already moved on. So they should have passed through here. And then the paradox was, well, where are they? Yeah, where are they? I mean, they should be impossible to miss. It's not like there's going to be one spaceship roaming around in our galaxy. It's like this is overcrowded. And of course, they're part of the same universe, so they have to deal with electromagnetics and gravity and all the things we deal with, they have to deal with too. So there's going to be signatures here with this crowded space that they're in, and so they're not here. You know, we don't see them, and they couldn't all be invisible. You know, that's even if they have that technology, they consume resources, they'd have heat, they'd, you know, things would be there. It's impossible for them to cover up all their footprints. So where are they? And it's considered to be a very strong paradox, because the rationale in it was judged, you know, people have gone back and redone the math and said, yeah, even making all very conservative, you know, assumptions about population and so on, even if you make real conservative assumptions, you still get to the same conclusion of where are they, because 1 billion years is just a very long time. So anyhow, there's a good answer to that paradox. Again, this model of mine just answers paradoxes, and this is a good one. What happens is, this is a virtual reality, okay? Now, the reason that everybody is certain that there must be other life somewhere in the universe is because there's literally trillions and trillions of suns, and there's just no reason why this little configuration we got here ought to be unique. Right? It shouldn't be unique. It ought to be replicated all over the place. So there's bound to be many, many, many other civilizations with people on it, or some kind of critters on them. They may not be like us, but something that suited that environment is bound to happen, because it's just so big and so much of it, so much potential. But if this is a virtual reality, consider the larger consciousness systems created this virtual reality for consciousness to help grow up. Now, in this particular planet, they've got about 8 billion seats in the simulator, okay, who are getting data streams. They have to produce about 8 billion data streams to get this done. And their idea is that they're increasing the evolution of the whole. right? That's the whole point. All these things because the whole evolves with the pieces. Now, what's the cost of another data stream? And what's the advantage of another person evolving? Well, all systems have this curve that, how they scale, more is better, more is better, more is not so much better, more is worse, more is worse, more is worse. You got some sweet point where you turn from more is better to more is not better. And it may be fairly even flat for a while on top, but eventually it goes downhill. So is 8 billion enough? Or is 8 billion, we could have 8 billion, we could have a billion, and one more added to that. Oh, yeah, that would be great and productive, worth another. Probably not. It's probably not that way. It's probably there's some number that is good. Now, I have been to other reality frames. At least it's, this is how it seemed to me. This is my experience. And they were like this one, but it wasn't this one. But it was a tight rule set. And, did it also have, it seemed to not have as much population as we do. But let's say it only had 5 billion. But were there other things in it? I'm sure it had lots of suns and, and things too. Trillions and trillions of suns. So you start looking at this and you're saying, well, I see way more seats, than would probably be worth it to the system, because it's just not another data stream, but it's another calculation of how this individual interacts with all the others and the effects that they have on each other. And it's not just a trivial thing to add another seat. There's a fair amount of work needs to be done to feed that seat and its interactions. So that then answers the question, is that all of those trillions of suns and their probable potential for life, they're just dots in the sky. Why would that ever be rendered? Just like if you're not going to render my guts inside, you just render what you see. That's all. So to us, those are just lights in the sky. They're dots of light in the sky. And to the Hubble telescope, well, they're big smears of gases and this and that and a lot of little stars and other kind of junk. But I only have to render that when the Hubble's turned on.
So it's kind of like the tree in the forest. If it falls, if there's no one there to listen, there's no point.
Yeah. So then you look at it and say, well, maybe 8 billion seats is enough, plus whatever it has in other places. Maybe that's enough. And maybe all of those just lights in the sky are nothing more than lights in the sky. And, at nighttime, they have to put lights in the sky, but in daytime, they don't even have to put lights in the sky. And if you don't have a telescope, they never have to put anything more than lights in the sky. And if you have a really big, expensive telescope, there's probably no more than a few dozen of those in the world anyway, well, then you have to give them another picture. But like we said, it's a random draw. What's going to be there? Well, there's 100 things that could be there. And here's a random draw from the probability distribution, the possibilities. That's what you show them. And then when that telescope looks elsewhere, you stop computing that. You don't compute that anymore. The telescope comes back, you compute it. Telescope goes away, you compute what's someplace else. And it's not much trouble at all. All the rest of that universe with its trillions and trillions of stars is not but that much effort for the larger galaxy system. All of this is a couple of lights in the sky, and that's it. And there's not a lot of interaction. There's not a lot of stuff it has to keep track of. It just has to keep track of what it's shown, what's been looked at, what it's shown. And it does that very easily. So it's a trivial thing for it to not populate anything more than here, because 8 billion is plenty. And adding another one probably doesn't pay for itself as far as, entropy lost for the total system and cost to the system. Matter of fact, the 8 billion are probably more than it needs, but it's going to keep doing it because we're here and we're doing things. So it's kind of locked into this experiment and this thing that's going on. So it'll do that. Perhaps if it's way more than it needs, then I guess we'll get some kind of terrible disease or some kind of big earthquake or a meteor will hit and reduce the numbers. Something will happen to reduce the numbers down to something better. But in any case, that's the answer to Fermi's paradox. We're it. And it's not a waste of all this there's billions of suns and planets at all. They don't really exist. They're never, ever rendered.
If we're not looking, it's not there.
Right. We're not looking. It's not there. So it's not a waste of resources. It's not a waste of billions of planets and suns at all. There's no waste. Matter of fact, rendering that stuff just to the point that we can see that it's there is trivial. It's almost nothing. It's probably less than just rendering one data stream for an individual. It's probably trivial than more trivial than that. So that's the perfect answer to the Fermi paradox, is that it's just us. This is a virtual reality. So that's what I find every time I try to apply this theory to just stuff, that's around. It always, there's the answer.
I'm gonna make a nice list for you, Tom. And I think when we have a round 2, I'm gonna try and just give you a whole bunch of scenarios and situations, and we can go tick them off one by one and see how TOE does for all of them. Your TOE, at least.
Great. I'd love it if there were 100 people doing that. I don't think I've got the only, thing and everything's done. It's just what I experienced and what I understand. I'm just one small piece of this. So I'd happy to find holes in it, things it doesn't do, things it doesn't, I don't have any pride in it being perfect. That's bad science.
Exactly. That's the point of this podcast. While I might not agree with everything you're saying, it's still the beauty of exploring these ideas and chatting about it, trying to understand each other's perspective.
That's the way I feel, because I look at it and I say, well, when I kind of talk with the technical people, I say, what I have is a model. It's just a model of reality and how reality works. So here's the model. Here's how it works. Here's how it came by. Here's what its purpose is. Here's why. Here's what we see. It's just a model. Now, if it works for you, good. Use it. If it doesn't, well, it doesn't. It's not. I'm not opposed to it changing. I'm not opposed to it being torn up and a different model replace it. I think that would be grand. If you have something that's better, replace it. That's what you're supposed to do with models. When you find something better, is you replace them. That would be wonderful. So I just see it as a model, and I offer it out to people to see whether it computes right answers for them. Does this model that talks about the intuitive side, does it explain your life and your questions and your things? Does it give you help? Can you understand now better where you are and where you're going and how you got there and who you are and your connections to people and all this? Is it better for you because you have this understanding? Well, if it is, good. If it isn't, then can't help that. Let it go. So that's kind of my attitude toward the whole thing. I'm just offering a model, but I can't get scientists to even look at the model. They won't even look at it.
Well, that's what podcasts like these are for, Tom. Hopefully it helps. Hopefully it gets some more people to view it. But I wish I could continue talking to you. It's been, for me, it's almost 12:30 p.m. a.m. Sorry for everyone watching.
Yeah, well, that's the magic hour when you start to melt and your mind gets fuzzy.
I feel my mind slowly fading off. If I didn't have work tomorrow, I definitely would have stayed. And I've been enjoying this conversation so much. For round 2, Tom, I've got so much planned. We can discuss the out-of-body experiences, the paranormal, and we'll just dive deeper into your.
Well, let me tell you just a couple of things, and before you forget, because this will go out sometime. You'll probably break it into pieces because nobody wants to listen to.
No, I actually don't. Generally, Tom. So what I do is I cut the
put out 3 hours, the whole thing. Oh well, okay. Only people have real tough dispositions if they're gonna.
The audience that watch this podcast, I've noticed, rewatch this content quite a lot. So there's a lot of returning viewers.
Oh, good.
Try and finish it. Yeah, so they'll go through it once, maybe even 5 times sometimes.
Oh, good. Well, then you've got really hardy viewers. The thing that I would like to let them know is that I have a couple of tools that will help them grow in this way. I told you that you have. The consciousness has 2 paths for processing. One's intellect and the other is intuitive. Most of us have not developed the intuitive side. We've developed the intellect side and honed it and polished it, and we've really got that humming. But the intuitive side, for most people, is not as good as it was when you were 3 years old. When you were 3 years old, you had your intuitive side was more developed than it is now for most people. And that's where all the paranormal things are. They're all over there on that intuitive side. And like you might think, if you had never developed your intellect any more than it were when you were 3 years old, your life would be very strange. There'd be a lot of mysterious stuff, and a lot of things wouldn't make sense, and you would have a ton of stuff you'd just never be able to do or understand. Well, expect that your intuitive side is like that. There's this huge possibility and potential over there on the intuitive side that most people have just never bothered to develop it. So that's the problem. And I have some tools for helping people develop that. I got a new website now that's a lot more instructive than the old one. If you go there, you'll find there's a lot more information that probably fill in a lot of gaps. But anyway, the thing I have a program. It's a 5-day program to teach you all the paranormal stuff, how to do it, what it means, how it works, how to approach it, that sort of thing, problems that people have, how to get over those problems. So the reason I made that is that I kept telling people, if it's not your experience, it's not your truth. So they said, okay, now help us have the experience. So I did. So I set all that up, and you can get that. You can find it.
I'll put a link to that in the description as well.
Yeah, so. You can find that. It's an audio program. It's just the audio. And I have a thing called Tom's Park, which is a thing that if you're having trouble with meditation, because meditation is the standard route that you go here. Meditation basically forces you to discipline your mind, discipline your thinking. That's all it is. You just have to learn how to turn your intellect off and let your mind hang empty with nothing in it until you want to put something in it and keep your intellect turned off. So anyhow, if that's it's a problem for people who are very intellectual, very big problem, and that's what gets in their way more than anything else. They can't turn their intellect off. They go to talk to their to their dead Uncle Fred, and as soon as Uncle Fred says hello, they go, "Who was that? Did you hear that? Was that me? Did I make that up, or was that real?" And that's their intellect stumping and judging the situation, and that kills it, and it's gone. So anyhow, Tom's Park is a way to get to the same places, and get the same development, but without having to go through meditation. It skips the meditation path altogether, and it gets rid of the transition. People trying to go out of body have this problem because the transition is the hang-up. I'm here, I'm in my body, I can tell it, here I am. Now I want to be out, but they can't get from here to there. But with this method in Tom's Park, you don't get from here to there. It's a slow process. You can be 10% there and 90% here, and then 15% there and 85% here, and it can go back and forth. It's a fluid process that can flow back and forth with no boundary. It uses the imagination instead of the discipline. You still have to develop discipline. You develop it in a different way. That's a lot easier. So that's another tool I have. And there's some others that if the people who listen to this say, "Oh, I'd like to develop my intuitive side because then I can talk to my children, my teenagers, mind to mind, and we can get a lot of things settled that right now are hard." Yes, you can. That's one of the things in there. Part of the paranormal things is talking mind to mind to people that get discussed. So I just wanted to leave that because I always feel bad when I just leave people without any way to find out for themselves, because I tell them, you got to find out for yourself, then you need to have some help to, otherwise it sounds like a cheap trick. Yeah, I'll go find out for yourself, No,
I completely agree. I think that that first person subjective phenomenal experience for yourself would make that experience a lot more valuable to them as well. And I think that's great, and I will definitely put links to that, Tom, because I think it's fundamental for them to actually develop their own tone.
And for the I have binaural beats for the ones who do want to meditate but have trouble. The binaural beats will stick you in a meditation state and hold you there. So that's what they do. And my binaural beats are probably different than anybody else's. There's a long history and a lot of experimental trial and error, behind them. So
I know that story, yes. I'm looking forward to diving into that the next time as well.
Yeah,
I'm very
they tend to work pretty well if you just want to boost. But warning comes with that. Just like any training wheels, if you're going to get really good at things, you need to eventually take the training wheels off.
yes. So you gotta let the beats go at some point and just do it on your own.
Yeah.
No. Thank you so much, Tom. I really appreciate it. Anything you want to say? Anything final words from your side before we close off?
No, it's been a really good talk. I enjoyed talking with you, Tevin, because you are a very informed and a very bright guy, and I like to talk with people who understand what I'm saying. I could tell you could follow me, and it wasn't that hard. You followed right along, and I could see you closing your eyes and you're thinking about it, and you got it. So it's been fun. So I would, if you people like it and you want to do it, let's do a part 2 and a part 3, and as much as you want until you've covered all the things that you want to cover.
So too many questions. I think we'll definitely do many parts. I think it's definitely a many part series, and that's the point of this podcast. It's just an opportunity to explore these wonderful topics.
Yeah. Okay. So good. I'd like to do that. I'd like to do that too. You're a good what is it? Interviewer. You're not really interviewing so much as you kind of steering the conversation a little bit here and there. So that's good. I've enjoyed the time too. Went from 2 to 5:30.
Yeah, it was like the time flew by. I'm surprised how late it is.
Yeah.
I actually had no idea the time until I really looked down.
Yeah, that's what happens when you're having fun. Okay. So
Thank you.
We'll do it again some other time once you get all this done and get it out and get the feedback from your viewers. Ask them what they want to hear about.
Definitely. That's something I'm going to do. So any questions, anything they're curious about, I'll make a list. I'll keep notes, and we'll cover all of it the next time and the future times as well.
Okay, good. Great seeing you.
Yes, Tom. Thank you so much, and have a great day.